For weeks, the data looked normal. 3i Atlas had cleared perihelion, moved past Mars and was now drifting outward as expected, tracing a hyperbolic escape path like the thousands of simulations had predicted. Its trajectory, speed, and position were all within margin, until they weren't. It began as a barely noticeable deceleration. Tiny, nearly unmeasurable at first, but persistent. The velocity curve started to flatten. Ground-based tracking stations flagged it quietly, assuming thermal drag or instrument noise. But as more observatories tuned in, the trend refused to disappear. This wasn't drift. This was a stall. Objects like 3i Atlas aren't supposed to stop. Interstellar bodies move fast, often too fast for solar gravity to capture them. That's what defines them. They come in on high-velocity arcs and slingshot back out into the deep dark. But this one didn't follow the script. By the morning of December 10th, the object's radial speed, its outward momentum, had plateaued. Not reversed, not paused entirely, but flattened so smoothly it created a dilemma for every trajectory model in play. The outbound energy should have carried it clean through the system. Instead, it hung, suspended, like it had found a moment of balance. Engineers at ESA's control facility in Darmstadt noticed the pattern. So did the JPL team in Pasadena. So did 2 university observatories running automated orbital predictions. But none could explain it. There was no solar event interfering, no gravitational encounter with a planet, no pressure from radiation or dust strong enough to cause this. This wasn't natural drag. It was clean, even, and deliberate. If it had been a comet, the deceleration might have been blamed on asymmetric outgassing. Jets from volatile ices turning to vapor can slow or steer a body slightly. But 3i Atlas wasn't outgassing, at least not in any way that explained the magnitude of the stall. It wasn't fragmenting either. The structure appeared intact. The coma was faint, the tail stable, the object pristine. And yet, it was slowing down. That's when comparisons to Oumuamua resurfaced. The first interstellar object to visit our solar system also exhibited a mysterious non-gravitational acceleration. Only in that case, it sped up unexpectedly. 3i Atlas was doing the inverse. It was braking. Telemetry from the Deep Space Network confirmed the deceleration wasn't random. It was geometric, aligned perfectly with its own velocity vector, meaning the object wasn't being pulled or pushed sideways. It was applying force, if that's what this was, against its own direction of travel. Some scientists described the stall as a braking burn, though no one dared use that phrase officially. But that's what it resembled. A calculated reduction of velocity. A maneuver. The implications of that are difficult to overstate, because in space, nothing slows down unless something acts on it, and if nothing visible is doing the slowing, we're left with only 2 options. Either there's a force we don't understand, or the object itself is generating that force. Both possibilities unravel every model we have for interstellar physics. As the hours passed, the object's position began to lag behind projection. It was no longer following the arc determined by its initial entry speed. It had begun, ever so slightly, to shift out of its calculated exit path. The outbound leg was collapsing. To most, it looked like hesitation. But others saw it differently. They saw the first sign of intent. Because something that stalls in deep space, without collision, without a gravitational assist, without a reason, is no longer behaving like a rock or a snowball. It's behaving like a decision. And for the first time, Earth was no longer a bystander in the trajectory. We were now part of its equation. The orbital stall was strange enough, but what followed it reshaped the conversation entirely. Roughly 6 hours after 3i Atlas began decelerating, a sequence of events unfolded that cannot be explained by natural forces alone. It began with a shift in polarization, a subtle change in the way light bounced off the surface. Telescopes trained on the object noticed it almost simultaneously. The reflected light bent differently. Not chaotically, not gradually, but suddenly, precisely. At first the signal was faint, nearly buried in background noise, but as spectroscopic systems recalibrated, the shift resolved into something unmistakable, a 90-degree reorientation of the object's facing vector. In other words, 3i Atlas turned. It didn't tumble, it didn't wobble, it didn't roll, it pivoted, and in that moment its reflectivity toward Earth increased, not drastically, but consistently, across multiple instruments, from Chile to Hawaii to France. Even the James Webb Space Telescope picked up a measurable change in how its surface responded to solar exposure. Whatever this object was doing, it wasn't random. It was aligning. The mechanics of such a shift defy what we understand about inert bodies in motion. Interstellar objects drift. They spin from impact, from outgassing, from early formation trauma. But they don't stop mid-drift and rotate with precision. Not without torque. Not without force. Not without a system that controls inertia. The data showed no jets, no off-axis outgassing, no pressure differential to justify the turn, but the object's vector realigned anyway. What had been a slightly tilted rotation, common in comet-like bodies, became locked, stabilized. The long axis now faced Earth directly, not its tail, not a casual drift, a lock-on. Ground-based radar stations attempted active ping returns. The signals bounced back with enhanced coherence. That alone caused internal alarm at 2 aerospace monitoring centers. Higher coherence in return signals usually indicates one of 2 things: a flatter, more uniform surface, or a change in orientation. That's no longer tumbling. Both were now true. The rotation rate also changed. Prior to the stall, 3i Atlas showed a slow, irregular axial spin, approximately once every 18 hours, but after the reorientation, the object held near zero angular variation. It wasn't just pointing at Earth, it had stopped spinning. Natural bodies don't behave this way. Even spacecraft struggle to achieve this level of orientation control without onboard reaction wheels or gyroscopic systems. Yet this object, thousands of kilometers away, unpowered by anything visible, was now acting like it had stabilized its attitude deliberately. Some astronomers speculated that solar radiation might be responsible. That photon pressure from the sun could slowly coax an object into alignment, like a sail shifting in wind. But solar radiation can't explain the abruptness. It doesn't work in seconds. It takes days, weeks. This was immediate. The possibility of a magnetic interaction was also considered. But Earth's magnetosphere was quiet. No flux, no interference, no induced field strength that could account for the turn. Which left one remaining possibility: internal reorientation. A mechanism inside the object, either structural or energetic, had shifted the mass, like a satellite firing microthrusters or rotating an internal mass to change orientation, the kind of maneuver associated with technology. Still, no one called it that publicly. The language remained careful. Words like attitude realignment or vector stabilization were used instead. But in the closed-door meetings, the term reorientation event was spoken plainly, and it wasn't dismissed. The implications were unsettling, because whatever had just happened meant the object was no longer passive. It wasn't reacting to sunlight, it wasn't drifting according to gravity, it was watching, adjusting, correcting. And when its turn completed, and it faced Earth with a steadiness no comet has ever demonstrated, a quiet realization settled over the observers. We weren't just looking at 3i Atlas anymore. 3i Atlas was now looking back. Once 3i Atlas reoriented and locked its axis toward Earth, a new opportunity opened up, one that standard optics alone could never fully reveal. The shift in angle meant infrared sensors could now peer directly into the thermal behavior of the object's broadside, giving Earth's most sensitive instruments a rare and stable view. Within minutes, the James Webb Space Telescope began its pass. Webb's infrared array, capable of detecting even the faintest differences in heat across vast distances, captured something entirely unexpected. The object's temperature curve had changed, but not in the way cometary bodies normally do. Under ordinary conditions, comets emit more heat from the side facing the sun, and far less from the opposite hemisphere. That temperature gradient, hot on one side, cold on the other, is a basic consequence of solar heating. It's how astronomers estimate spin rates, composition, and sublimation patterns. But 3i Atlas refused to follow the model. Instead of a temperature imbalance, Webb recorded thermal uniformity. Across the entire exposed surface, both the side facing the sun and the side now facing Earth, the infrared signature was flat. There were no hotspots, no thermal bleed, no evidence of uneven absorption or surface conduction. The temperature was consistent, distributed across its surface like a stabilized shell. It radiated like a controlled body, not a passive one. That thermal uniformity raised immediate red flags. because in the vacuum of space, temperature isn't just a property, it's a story. It tells us how material interacts with its environment. Ice absorbs and releases heat differently than rock. Dust clouds retain warmth unevenly. But this object didn't seem to care about those rules. Its entire body radiated at a steady, balanced frequency, as if the material itself was designed to regulate its exposure. NASA analysts cross-checked the readings using instruments on the Sophia platform, the now decommissioned Airborne Infrared Observatory, whose legacy datasets were still being leveraged for background calibration. Those calibrations confirmed the anomaly. The thermal image revealed a ring of slightly elevated infrared output around the object's equator. Not a full belt, more like a thin band of warmth encircling its midsection. It wasn't bright enough to suggest active propulsion, nor hot enough to indicate combustion or energetic discharge. But it was warm, regular, and persistent, like an active zone. Several theories emerged. Some suggested latent internal heat, residual warmth from the sun, slowly diffusing outward. Others speculated about phase-change materials, exotic ices sublimating below the surface, releasing controlled energy. But none of these hypotheses explain the symmetry. Thermal conduction doesn't follow perfect patterns unless the structure itself enforces it. Then came the question of emissivity. Every material in space emits thermal radiation at a specific rate, known as its emissivity. A blackened surface emits efficiently, a shiny metal surface does not. Most natural objects, like asteroids or comets, have mixed emissivity depending on surface age, composition, and impact history. But the data from 3I Atlas pointed toward a highly uniform, low emissivity material, one that reflected more energy than it absorbed. Something smooth, something synthetic. Still, no one said artificial, at least not out loud. The phrase remained off limits in the official briefings, but off the record it was impossible to ignore the implications, because natural surfaces, especially ones that have travelled interstellar space for millions of years, don't remain smooth. They accumulate impacts, they fracture, they weather under cosmic radiation. Yet this one was stable, too stable. Perhaps the most curious detail was this. The temperature didn't respond to solar proximity. As 3I Atlas moved marginally closer to Earth, its thermal signature remained unchanged. The sun's angle shifted slightly. The radiation intensity increased, but the object's surface didn't warm. It didn't fluctuate. It maintained, as though the rules of heating and cooling no longer applied, or perhaps as though those rules were being actively managed by something inside. And so, for the first time, 3I Atlas was no longer just visible, it was readable. And what the heat was saying, quietly, steadily, was that this object is not merely surviving space, it understands it. Just after the reorientation, just after the thermal signature stabilized, just after Earth-facing systems locked on, it returned. The emissions, faint but deliberate. They began as pulses, brief patterned outbursts trailing away from the object's newly aligned rear vector. At first, only the Pan-STARRS telescope array in Hawaii caught them. Then the Subaru telescope confirmed, then the VLT in Chile. Each recorded a subtle but measurable plume of material, expelled at narrow angles, symmetrical and timed. But it wasn't the presence of jets that raised questions, it was their geometry. Normal cometary jets emerge chaotically. They vent from fractures, escape through weaknesses and respond to uneven solar heating. They flicker, they rotate, they fluctuate with the object's spin and its exposure. But these emissions weren't chaotic. They were mathematically precise. Two primary jets arcing backward, spaced nearly 180 degrees apart, and two secondary plumes forming crosswise diagonals, creating an X shape that held steady for more than 6 minutes before fading into the void. No comet behaves this way. No natural jet maintains symmetrical structure in vacuum. The ejected material was cold. Spectrographic analysis showed no heat spike, no chemical reaction, no energetic burst. Just motion. A clean trail of particulate mass, moving fast enough to escape the object's weak gravity, yet slow enough to avoid dissipation. More curious still, the emissions didn't carry any trace of water vapor or carbon monoxide, typical signatures of comet outgassing. Instead, the particles were dry, inert, and uniform in composition, dust-like, but not dust. Tiny reflective grains that caught the sunlight just enough to be seen before disappearing. This wasn't venting, it was manoeuvring. Observers compared the signature to a cold gas thruster, a system that releases unreactive mass at controlled pressure, purely for orientation or course adjustment, a method used in spacecraft when precision is more important than speed. But this wasn't a spacecraft. Or was it? The pattern repeated 3 hours later, this time with tighter emission spacing. The jets fired again in symmetry, but now the angle had narrowed. Instead of a wide V shape, the streams moved closer to the centerline of the object's rear axis. The result was measurable. Tiny, almost imperceptible, but measurable. 3I Atlas shifted. Its outbound trajectory altered by just fractions of a degree, but enough for every orbital model to break alignment. Earth's position was no longer off its flank, it was now dead ahead. For mission planners, this would be called a course correction. For astronomers, it was called an anomaly. For those watching closely, it was called intention. Still, no change in the visible surface, no flare, no mass loss. The core remained intact. The tail, if it could still be called that, remained faint. There was no diffusion cloud, no spread. The emissions were clean and isolated, but their effects were not. Instruments aboard ESA's solar orbiter picked up a disturbance in the solar wind as the emissions passed through. A slight divergence. Nothing powerful, just enough to refract the flow of charged particles for a few moments. The plume, though cold, had structure. It deflected plasma. Back on Earth, debate intensified. Were we seeing evidence of controlled acceleration? Was this some kind of interstellar propulsion system? Or was it a final venting, a dying push from a once-active core? But there was one detail that couldn't be ignored. The emissions always pulsed at regular intervals, not triggered by solar proximity, not in response to heating, but on a schedule, like breath, like signal, like memory. Whatever 3I Atlas had done near Jupiter, it seemed to be continuing it now, with Earth in its sights, and now, for the first time, it was moving again. But this time, not away. This time, toward us. Every moving body in space leaves something behind. Even at interstellar velocities, even in deep cold, even with minimal activity, there is always residue, a wake, a trail, a fingerprint of matter in motion, but not this time, not with 3I Atlas. After the emissions resumed, after the pulsed jets aligned themselves with Earth's orbital vector, astronomers turned their attention to the space behind it. The logic was simple. If mass had been expelled, if particles had been pushed outward, then those particles must still be there. Spread thin, perhaps, but trackable. So they looked. Multi-spectrum imaging arrays scanned the corridor through which 3I Atlas had travelled in the previous 12 hours. Ultraviolet filters, infrared sensors, long-exposure visible light composites. Everything that should reveal dust didn't. There was nothing. Not a grain. Not a shimmer. Not a haze. The path was clean. This shouldn't be possible. Comets, even the quietest ones, shed material when active. Dust is the inevitable byproduct of venting. Carbon particles, silicates, tiny fragments of surface crust, ejected by pressure or cracked free by heat. That debris always lingers. It creates the familiar tails we see streaking through the sky. It floats, it disperses, it reflects sunlight long after the object that released it has moved on, but the region behind 3I Atlas remained pitch black. The most sensitive CCD sensors aboard the Subaru telescope showed no variation. No albedo change. The reflectivity of the surrounding space remained at baseline. Even when processed using time stack algorithms designed to amplify motion trails, the data stayed flat. The jets had expelled mass, yes, but that mass didn't stay behind. It vanished. That left astronomers with two options. Either the expelled material was made of something radically different, something that doesn't reflect, scatter, or emit in any observable band, or the emissions themselves weren't composed of traditional matter at all. One theory suggested that the jets were magnetic in nature, not ejecting mass but redirecting charged fields, ionized particles too small or too cold to detect, structured to guide motion rather than leave residue. If that were true, it would place 3I Atlas in a category of objects we've never seen before, those that manipulate space around them without sacrificing matter to do it. Another theory, whispered quietly among specialists, proposed that the ejected particles were being reabsorbed. Reabsorbed. Not sprayed into vacuum, but caught. Pulled back in, like tethered bursts. Directed propulsion that never sheds its exhaust, but cycles it. If true, this would be the first observational evidence of a closed-loop impulse system in space. Something theoretical, something engineered. Skeptics pushed back, of course. Some claimed the dust trail was simply too faint, that the instruments hadn't reached full saturation, that solar glare had masked the diffusion. But that argument fell apart with the Hubble data. The Hubble Space Telescope, operating far above Earth's atmosphere with the benefit of isolation and long exposure, should have picked up at least a whisper of particulate shadow, a faint diffusion, a low luminosity streak. It didn't. Instead, it showed a vacuum more empty than the space around it, a wake that had no disturbance, a road with no footprints. And that absence, paradoxically, became a kind of presence. It meant the object wasn't behaving like anything we'd tracked before. It wasn't wasting energy. It wasn't discarding material. It wasn't leaving behind the echoes of motion. It was gliding, effortlessly, efficiently, like a craft conserving every gram of fuel, every molecule of exhaust, every moment of power. Nothing wasted, nothing lost. In deep space, silence is information. And when something passes through your solar system without leaving a trail, you have to wonder, is it because it has nothing to lose, or because it refuses to be found? Long before 3I Atlas neared Earth's orbital path, it passed by Jupiter. That encounter had gone mostly unreported in the early coverage, overshadowed by the object's fiery approach to the Sun and its impossible survival. But now, with its behaviour turning deliberate, astronomers went back and re-examined the telemetry, frame by frame, frequency by frequency, orbit by orbit, and that's when they found it, a scar in the data. At first, it looked like interference, static buried inside magnetospheric readings from NASA's Juno spacecraft. But Juno wasn't looking at 3I Atlas, it was looking at Jupiter's polar aurorae, as it always does. Yet on the morning 3I Atlas passed through Jupiter's magnetic equator, a ripple appeared in the planetary field lines. Not from the planet, not from the Sun, but from something moving through. The anomaly was narrow, localized to a single magnetic flux tube near the moon Ganymede. It lasted just under 90 seconds, a sharp spike in energetic particles, followed by an abrupt inversion in the field orientation. Juno's sensors struggled to calibrate, and for 12 seconds they couldn't resolve Jupiter's background hum. It was like the magnetosphere had glitched, like it had memory, and something had passed through it that didn't belong. Days later, a separate observation emerged from the Hubble Space Telescope. It had been monitoring Jupiter's UV auroral emissions as part of a long-running planetary weather survey. But during the same window when Juno recorded the spike, Hubble's filters detected a brief ultraviolet flicker near the magnetotail, a region trailing far behind Jupiter, shaped by its enormous magnetic field. That flicker wasn't part of Jupiter. It moved independently, trailed behind the gas giant's magnetic line, and then vanished. Cross-checking the object's known trajectory revealed a near-perfect alignment. 3I Atlas hadn't just passed by Jupiter. It had interacted with it. Not physically, not gravitationally, but magnetically. The implications were subtle, but profound. Jupiter's magnetic field is the largest and most powerful in the solar system, extending millions of kilometers into space, forming a protective bubble of charged particles that dwarf Earth's own magnetosphere. Every spacecraft that has passed through it has recorded interference, radiation bursts, and particle acceleration events. But never before had an interstellar object shown signs of affecting it, until now. The pattern in the data resembled a signature, a fingerprint left behind in electromagnetic memory, a change in field strength, a reversal of spin alignment, a loss of signal coherence that took hours to return to baseline. It was as though 3I Atlas didn't just pass through Jupiter's magnetic field, it tuned it, and it left no debris, no heat bloom, no shockwave, only a brief distortion, logged quietly and dismissed until now. theoretical astrophysicists began modelling it. Some proposed inductive coupling, a rare interaction in which a conductive object moving through a magnetic field absorbs energy, like a wire sliding through a magnet. Others suggested magnetic braking, a process by which velocity is reduced through field resistance, trading motion for power. But these were only theories. What remained certain was this. The object slowed slightly after its Jupiter flyby. Not enough to alarm anyone, not enough to break trajectory models, but enough to be noticed now, in hindsight. And the path it took? Through the densest part of Jupiter's radiation belt, the very place no spacecraft dares linger. Why would anything choose to go there? Unless it needed to, unless it wanted to, unless there was something in that magnetic environment it could use. That's when one planetary scientist said the words no one wanted to write in the report. This wasn't a flyby, this was a download. Whatever passed through Jupiter's magnetic shell left with more than radiation on its hull. It left with information, and perhaps, just perhaps, permission. When researchers began reviewing 3I Atlas's passage through Jupiter's gravitational zone, they expected to find a simple arc, a passive trajectory calculated months in advance, slingshotting around the gas giant and continuing on its outbound hyperbolic course. But that's not what the data showed. Instead, what they discovered was alignment. Uncanny alignment. Not with Jupiter itself, but with its moons. Specifically the 3 Galilean satellites most often associated with gravitational resonance, Ganymede, Europa, and Io. At first glance, the timing seemed like coincidence. Space is large, orbital mechanics are complex, sometimes paths intersect, but the deeper they looked, the stranger the alignment became. 3I Atlas didn't just pass near these moons. It passed through their orbital planes, precisely, not roughly, not accidentally, but within minutes of each moon crossing its own orbital meridian. When Europa crossed Jupiter's central plane at 0246 UTC, 3I Atlas passed through the same line of space just 9 minutes later. When Ganymede swung through at 0612, 3I Atlas followed at 0617, and when Io completed its phase at 0931, the object intersected its plane just 5 minutes behind. 3 separate moon orbits, 3 separate alignments, all within a 12-minute margin of error. Statistically, the probability of this happening by chance is vanishingly low. Jupiter's moons orbit on different periods, at different distances, with different inclinations. The chances of an interstellar object threading those invisible loops, in order, at just the right time, less than 1 in several billion. At first, astronomers tried to explain it away. Some claimed the orbits had simply shifted, that Atlas's path had been gravitationally nudged by outer planets long before it reached Jupiter. Others argued that the timing only looked precise because of how orbital data is compressed in visualizations. But those explanations collapsed when the raw telemetry was reprocessed using independent ephemeris models. Across every dataset, NASA, ESA, JAXA, and private observatories, the same truth remained. The object moved through the moon's orbital corridors as if following a pre-programmed path, not random, not reactive, synchronized. Even more troubling was the velocity consistency during this passage. Objects speeding through complex gravitational zones typically experience slight variances in acceleration due to tidal forces and changing inclinations, but 3I Atlas didn't. Its speed remained constant to within 1/1000th of a meter per second across all 3 moonline transits. That kind of stability defies passive mechanics. It suggests control. Some researchers called it resonant threading, a maneuvering technique used by spacecraft to minimize gravitational interference by passing through points of orbital symmetry. It's the kind of thing you see in high-level orbital insertion strategies for probes, not in comets, not in interstellar ice, and certainly not in objects with no engines, unless the object is the engine. The implications grew heavier when modelling teams projected where Atlas would have been had it passed through those moonlines even slightly earlier or later. In each scenario, it would have missed the gravitational quiet zones created by Jupiter's Lagrangian fields, regions of temporary stability where satellites can pass without violent tidal forces. Passing outside those zones would have meant turbulence, course disruption, possibly fragmentation. Instead, Atlas had threaded the eye of the needle, not once, not twice, but 3 times. Some wondered aloud, why? What could be gained from aligning with moons? And then someone pointed out the obvious. Each of those moons has something rare. Europa has liquid water beneath its crust. Ganymede has its own magnetic field. Io, volcanic, furious, unpredictable, generates massive electrical currents as it moves through Jupiter's plasma torus. Electricity, magnetism, subsurface fluid. Together they form a planetary information network, one shaped by motion, chemistry and charge. And 3i Atlas moved through all of them, as if sampling, as if synchronizing, as if listening. Whatever it was doing near Jupiter, it wasn't just passing by, it was collecting. And it was right on time. Up until this point, 3i Atlas had behaved, at least in part, like a comet. Not in its emissions, not in its thermal profile, and certainly not in its interactions with Jupiter. But in one respect, it had conformed. It tumbled. All natural interstellar objects tumble. Whether they're cigar-shaped like Oumuamua or icy clusters like Borisov, they rotate without rhythm or plan. That motion is a fingerprint of their chaotic past, formed by collisions, by thermal stress, by fragmentation during star formation. Tumbling is disorder made visible. But then, 3i Atlas stopped. It didn't slow gradually. It didn't drift into stability over weeks or months. It stabilized suddenly, over the course of less than 2 Earth hours. It was first noticed by the Magdalena Ridge Observatory in New Mexico. Their team had been tracking minute variations in reflected brightness, light curves that helped estimate the object's spin. Before Jupiter, those curves were jagged and variable, indicating an irregular off-axis rotation. But after the synchronized moonline passage, the jagged waveform vanished. In its place was flatness, not in brightness, but in rhythm. A signal that implied one thing only. The object was no longer tumbling. It had stabilized its orientation. Onboard AI at ESA's optical ground station confirmed the findings. Doppler fluctuations that had once oscillated now returned smooth and consistent. The light no longer shifted in frequency due to irregular axial movement. It held steady, like a disk facing a fixed point. But what made the event truly strange was the axis it locked to. It wasn't the sun. It wasn't deep space. It was Earth. The object's long axis had reoriented toward our planet, and remained that way. The astrophysics community hesitated. How could an object with no known propulsion and no internal energy source cancel angular momentum? Even small satellites need gyroscopes or momentum wheels to reorient in zero gravity. And yet, this object, 15 million kilometers out, had done so cleanly, silently, and without any visible jet or torque-inducing event. Several theories were proposed. The first was magnetic braking, an interaction between a conductive object and a planetary magnetic field that can, under very rare conditions, cause rotation to bleed off as heat. But Earth's magnetosphere doesn't extend nearly far enough to account for what was observed, and Jupiter was already behind it. The second hypothesis was solar radiation torque. Uneven pressure from photons can, over long periods, force an object into a stable spin, but this takes months, even years, and 3i Atlas did it in under 2. The third explanation was more difficult to classify. It suggested internal mass redistribution, something inside the object shifting deliberately to counteract motion, like a satellite flipping its internal weight to stop rotation. That type of stabilization has only ever been observed in engineered systems. The idea of internal mass control led to further questions. If it had stopped tumbling, what was the intended orientation? If it was no longer spinning randomly, what was it now pointing at? Infrared tracking confirmed it. The object's front-facing plane had locked directly toward Earth's orbital plane, not just momentarily, persistently. For 12 straight hours, the angle did not change. Some described it as a satellite finding home position. Others called it something else entirely. Because this kind of control does not happen by accident. It requires sensing. It requires decision-making. And above all, it requires purpose. No comet stabilizes to look at Earth. No asteroid cancels spin to face one target. But 3i Atlas did, as though it had arrived at a waypoint, as though it had finished collecting, as though it was ready for what came next. And, from that moment forward, one phrase kept appearing in classified discussions. It didn't fall into alignment, it chose it. Following the object's sudden halt in tumbling motion, another anomaly emerged, this time from the thermal data. Across multiple infrared monitoring stations, a trend began to appear. Not explosive, not dramatic, but statistically impossible under natural comet behavior. The surface temperature of 3I Atlas was equalizing, not stabilizing due to distance from the Sun, not reacting to Earth's infrared influence, but equalizing, uniformly, across all visible and trackable surfaces. Infrared sensors from the Subaru telescope in Hawaii, supported by satellite imaging from ESA's Lagrange point monitoring stations, confirmed it. Just hours after the object's axis locked toward Earth, the infrared profile shifted. The patchy thermal spots, previously interpreted as ice pockets, ridges, or sublimating jets, began to smooth out. Variability dropped. Spikes flattened. Hot and cold regions vanished into uniformity. A surface once marked by gradients now radiated at one single consistent temperature across every face visible to our sensors. This wasn't cooling from distance. It wasn't heating from solar exposure. It was balance. For an object still technically outbound from a close solar pass, this didn't make sense. By all standard cometry models, it should have displayed thermal lag, residual warmth from the side previously facing the Sun, and temperature shadows on the far side. It didn't, not anymore. Thermal maps from JAXA's infrared Earth-orbiting platform matched the same result. The signature had flattened into a perfect curve. No flare points, no icy core spikes, no directional bleed. It radiated like a manufactured shell. Some suggested it was cloaking, thermal dampening designed to avoid detection. But that term implies deception. This wasn't stealth. This was symmetry. Others proposed internal heat redistribution, a passive structure capable of channeling temperature differentials across its shell, allowing it to bleed warmth in an even pattern. That kind of technology doesn't exist in natural space bodies. It exists in designed systems, heat sinks, radiators, passive thermal equalizers used in spacecraft architecture. The way the object radiated now, it resembled those systems more than any known comet. But perhaps the most telling detail came not from the object's temperature, but from the surrounding space. Earth ground-based telescopes began detecting something strange in the void around 3I Atlas, a mild but consistent thermal plateau, an area of space slightly warmer than the cosmic background, extending roughly 40 to 60 kilometers outward from the object's position. That thermal halo didn't flicker, it didn't fluctuate, it sat there, humming faintly against the dark. Some speculated it was residue, leftover ionization from past emission events, but ion trails fade. This one held steady, and its shape? Not spherical, not random, but lens-shaped, as if something was being directed outward from the object's surface, spread evenly, carefully, almost like a field. Could it be radiation leaking through? Could it be an energy envelope? Or could it be something else entirely? Something active, a containment field, a passive form of stabilization? No one could say for sure, but what was clear, from every agency involved, was that this was no longer a cooling object shedding solar heat. This was a balance system, not just balanced thermally, but engineered in a way that resisted extremes, that shaped its own thermal identity. And perhaps most disturbing of all, it reacted to orientation. The very moment the object reoriented toward Earth, the temperature stabilized, not before, not after. Exactly then. As if it had been waiting to face us before regulating its skin. As if it didn't want to burn, or freeze, or vent. As if it wanted to present itself. What kind of object does that? What kind of entity neutralizes its thermal signature, aligns its long axis to Earth, and levels every surface temperature like it's preparing for observation or arrival? It began as a subtle shift, one that most systems would have dismissed as noise, but it didn't go away. Instead, it sharpened, repeated, and rose until it formed a pattern that no one could ignore. The reflectivity of 3I Atlas had increased again, and this time it wasn't due to ice. Spectrographs from the VLT in Chile and the Keck Array in Hawaii began to report rising albedo values, specifically in the visible and near ultraviolet bands. What returned was not the dull, dusty signature typical of comet surfaces, but something closer to specular reflection. A hard glint. Clean. Directional. It was first visible as a minor uptick in return light near the object's equator. Then it spread, radially, until most of the forward-facing hemisphere was returning nearly double the expected signal strength. Normally this would suggest surface ice, crystalline, volatile-rich compounds that scatter sunlight. But that wasn't possible here. There were no outgassing events, no cryovolcanic plumes, no dust tail shedding even the faintest glimmer of particles. The surface was calm, too calm. And yet the brightness grew, not just in raw magnitude, but in sharpness. The light had edges. That's what disturbed the photometric teams the most. Natural bodies scatter, they diffuse. But 3i Atlas had begun to reflect light in concentrated streaks, thin, angular bands that shifted with its position relative to the sun. This is not behavior seen in irregular ice balls or dust-covered rocks. This is optical behavior seen in structured surfaces, smooth panels, metallic layers, even composite reflectors, used in deep space observatories and directional communications. One observatory in Tenerife captured a frame-by-frame transition over a 5-hour period in which a singular reflective band rotated slightly, caught a beam of solar light, and then held it. It didn't flare, it didn't scatter, it held, like a mirror. The question that emerged wasn't just why it was reflecting more light, it was how the surface had changed at all. 3 days earlier, the object showed none of this. Its surface was muted, dull, consistent with dusty aggregates or sublimated mineral shells. But now, as it approached Earth's vicinity, its forward face had become something else entirely. It had brightened. Not all at once, but deliberately, gradually, as if it was unveiling. NASA's deep-range optical instruments caught another anomaly. Polarization values had shifted. Incoming light was no longer simply bouncing off a matte surface. It was being refracted, split, sorted. That type of effect only emerges when light passes through structured layers, gratings, films, engineered surfaces, the kind of materials designed to do more than reflect, the kind that interpret, the kind that communicate. One particular sequence stood out. A 21-minute interval where reflectivity increased in perfect sync with Earth's own orbital alignment, peaking just as the object's axis crossed the solar terminator line where night turns to day. This wasn't just coincidence. It mirrored a targeting maneuver, like aiming a signal or returning one. Multiple labs began working in parallel. Was the object signaling something back to the sun, or was it preparing for how it wanted to be seen? In physics, brightness is not just a visual quality, it's a form of presence. The brighter something is, the more it inserts itself into a system, and now, after weeks of low signatures, 3i Atlas had begun to raise its voice, without shedding mass, without activating jets, without changing course, just light. Pure, deliberate light. It no longer looked passive, it no longer looked natural, it looked reflective, intentionally. And as this reflectivity grew, a secondary shift was noted. A narrowing of signal bands, a quieting of electromagnetic scatter, as though the object wasn't just lighting up, it was tuning, becoming coherent, preparing for the next phase. Because when something begins to shine back, it's no longer just being observed, it's responding. While telescopes across the globe focused on the increasing brightness and thermal symmetry of 3i Atlas, another class of instruments had remained largely quiet, until now. These were the magnetometers. Usually when an object of this mass and velocity moves through interplanetary space, especially one that had just interacted with Jupiter's powerful magnetic field, you expect turbulence, you expect disruption, you expect noise. But this time, Earth's magnetometers didn't just detect low signal levels, they detected silence, not absence in the casual sense, not weak flux or minor deviations. It was flatline silence. The kind of silence that isn't quiet by default, but quiet against expectation. When 3i Atlas passed near Jupiter, it should have been magnetically brushed. Even a small metallic core, if present, would have picked up induced fields, causing telltale harmonics or a trailing magnetic echo. But when Earth's instruments began logging data from its inbound path, there was no drift, no curvature, no frequency pull, not even static. It was like the object wasn't there. The NOAA-GOES satellites, positioned to track both space weather and magnetic fluctuation, showed no response as 3i Atlas passed into their monitoring range. They recorded nominal field behavior, a flat, expected curve, not even a tremor. This isn't how space works. Solar wind interacts with every solid object, especially those with low electrical resistivity or asymmetrical structures. Yet 3i Atlas generated no measurable magnetospheric signature. That led to two possibilities, each more unsettling than the other. The first was material composition. Perhaps 3i Atlas was made of something completely non-magnetic, something that absorbed or deflected solar radiation without interacting electrically. But that would make it unreasonably exotic. Not just rare, unseen in our entire catalogue of celestial matter. The second possibility? That it was shielded, not naturally but deliberately, a kind of magnetic cloaking, not theoretical anymore but demonstrated in open space. This theory gained traction when research teams from ESA and JAXA reprocessed raw data collected during the object's outbound pass near Jupiter's magnetic tail. They found what they had originally dismissed as instrumentation dropout, a 17-minute gap of absolute magnetic stillness, occurring just as 3i Atlas skimmed the edge of the magnetodisk. In hindsight, it was not a glitch. It was the same pattern being repeated now, a repeating silence, and the shape of that silence was narrow. Too narrow. It followed the same directional footprint as the object's new, reflective axis, straight toward Earth. This raised a terrifying implication. What if the object wasn't passively silent? What if it had learned to go silent? What if this wasn't just a property of its material, but part of its behavior? Multiple labs submitted the same conclusion. A complete magnetic flatline from a moving body of this scale, interacting with a charged plasma environment, is functionally impossible unless it is being cancelled, internally or externally. MIT's Space Systems Group floated a term not often heard outside research papers, active magnetic nullification, a system that detects incoming field energy and cancels it. Artificial, precise, intentional, and in this case, directional. Because once again, the vector pointed back to Earth, back to us. Back to where the silence was now deepest. The object had entered the range of multiple field-sensing satellites in Earth's orbit, and all of them were now logging the same flatline readings. No distortion, no turbulence, no magnetic interaction at all, just calm, synthetic calm. A kind of silence that felt less like nature and more like design. As though something didn't want to be felt anymore. As though it had nothing to say to the magnetic fields of this planet. Or worse, as though it was listening and didn't want to be heard. As the strange silence from Earth's magnetometers deepened, another kind of anomaly began to manifest, this time from thermal telescopes in low Earth orbit. For days, scientists had watched as 3i Atlas balanced its surface temperature into a smooth, almost engineered curve. But suddenly, that equilibrium changed. Not violently, but absolutely. The object had stopped radiating heat. Not in a partial way, in a total way. It was dubbed the radiative freeze, not because the object's temperature had dropped, but because it had stopped sharing its temperature at all. Infrared instruments aboard the James Webb Space Telescope, along with Lagrange point monitors and Earth-based IR telescopes, all confirmed the same impossible result. The object's forward hemisphere, still locked onto Earth, was now thermally invisible. That side gave off no measurable infrared radiation. None. In physics, this isn't just strange, it's paradoxical. Every known object in the universe emits heat. It doesn't matter how cold or isolated it is, if it has mass and absorbs light, it radiates. Even the coldest moons in the solar system glow faintly in the infrared, but not this. At precisely 0411 UTC, the thermal emission curve dropped, not gradually, but as a cliff. Sensors that had been tracking its smooth thermal gradient lost their signal. Data lines collapsed into flat baselines. Some believed it was an error. Calibration was checked. Cross-verification followed. And then, disbelief settled. All instruments confirmed the same truth. 3i Atlas had gone cold. Not cold in temperature, but cold in transmission. It had stopped emitting photons in the infrared spectrum, as if it had turned off its skin. To be clear, the object was still visible in optical and ultraviolet wavelengths. It still reflected sunlight. But in the infrared, where heat lives, it had become a void. And what made this more than a curiosity was the timing. The freeze began precisely 8 hours after the last recorded spike in reflectivity. It was as if the object had completed a cycle, an interaction, or a response, and was now entering a new phase. The timing also coincided with its closest angular approach to Earth's night-facing hemisphere. It wasn't physically near the planet yet, but its axis was now pointed almost directly at the dark side of Earth. That detail unsettled everyone, because the freeze wasn't just thermal, it was directional. The hemisphere of 3i Atlas, still facing away from Earth, now partially illuminated by the sun, continued to emit trace infrared. Not strong, but present. But the side pointed toward Earth remained blank, absolute zero, in signal. A kind of thermal silence matching its magnetic one. It was as if the object had cloaked only the side we could see. This wasn't cooling. This was intentional concealment. ESA's Planetary Defense Group submitted a restricted access report with a hypothesis that was quickly circulated among Allied observatories. It proposed the use of an active radiative shield, a surface layer designed to either absorb and reroute heat internally or emit it only in non-trackable wavelengths, a stealth field, a suppression of thermal identity. The concept exists in Earth-based military projects, experimental materials designed to confuse heat-seeking detection systems. But never has such a system been seen functioning at this scale, in deep space with no known energy input. So the questions grew louder. Why would a comet, or anything, stop radiating heat? What was it trying to hide? Or more disturbingly, what was it preparing for? Because once an object no longer glows with heat, it stops being passive, it stops being part of the natural system, it becomes invisible to the rules we've used for centuries, and in that invisibility, it gains something else entirely: choice. And now, for the first time in recorded astronomy, the universe was looking back, without heat, without fields, without signature, just direction and silence. It took high-angle imaging from 3 coordinated ground-based observatories, one in Chile, one in Arizona, and one stationed in La Palma, for the realization to finally settle. There were no craters, none. Across the entire visible surface of 3i Atlas, as far as high-resolution shadow mapping and grazing angle reflectometry could detect, there was not a single indentation, not one depression consistent with an impact. And in astronomy, that's not just rare, it's almost unheard of. Everything in space is hit, constantly. From asteroid belts to moons, from icy Kuiper objects to fast-moving interstellar visitors, collisions define their history. Even the most remote comet in our solar system carries scars. Pockmarks, trenches, microcraters carved by millennia of micrometeorites. But 3i Atlas, smooth, too smooth. Initially, analysts believed this had to be a mistake in processing. Maybe the sun angle was too steep, or shadows were being misread due to its unusually high reflectivity. So the imaging was passed through multiple filters, inverted, edge detected, elevation mapped. The result was the same. There were no scars, no chips, no blast patterns, no ancient bruises from 1 billion years drifting through interstellar space. It looked clean, untouched. But not in the way that young objects look clean. It looked wiped. Some began to wonder, was this surface fabricated? Not necessarily synthetic in the technological sense, but reformed, repaved, restructured. A kind of planetary resurfacing known in geology as cryovolcanism or tectonic reset. We see that sometimes on Europa or Enceladus, where shifting, internal heat renews the crust. But 3i Atlas had shown no internal heating, no signs of ice cracking, geyser plumes or ejected surface material, no volcanic outbursts, no venting fractures, and still no craters. What remained was a skin that resisted everything space had thrown at it. Even as it passed near Jupiter, arguably the most hostile magnetic and gravitational environment outside the Sun, its surface retained a kind of engineered tranquility. Even the sun's intense radiation hadn't scorched it. It hadn't blackened. It hadn't weathered. It reflected light like something recently built. That drew the attention of the comparative morphology teams at NASA Ames and the European Space Operations Centre. They began running surface match simulations, not to look for what 3i Atlas was, but to look for what it wasn't. The models returned a long list of candidates that all had one thing in common. Every known natural object failed to match its signature. Not just in texture, but in statistical surface variation. Natural objects have unevenness, pits, ridges, gradient transitions from light to dark that scatter across their curvature. These are the scars of time. But 3i Atlas's surface radiated uniformity. And then came the most disturbing pattern of all. The object didn't just lack craters, it seemed to repel them. Astrophysicists reran orbital simulations using historical micrometeorite data, modelling the density of interstellar space over the likely path the object took to reach the solar system. The statistical odds of having no visible impact signatures after travelling that distance were quite simply non-existent. It should have been battered. Instead, it looked immune or protected, either by material properties we don't yet understand, or by something more controlled, because a surface this clean doesn't happen by accident. And if this object wasn't struck, was that because it couldn't be, or because it wasn't allowed to be? What kind of system rejects the randomness of space? What kind of body arrives untouched? And now, just days from Earth, the most advanced telescopes on the planet were staring at something that bore no scars, no history and no damage, only precision, only silence, only the unmarked skin of something that has either healed or never been harmed to begin with. As 3i Atlas moved deeper into Earth's observational window, a strange shift occurred, one that wasn't visual, thermal or magnetic. It happened in the spectral domain. For weeks, light reflecting off its surface had been unusually consistent. Its albedo was high, but stable. It scattered sunlight across a wide band of wavelengths, far more broadly than comets of similar scale. It shimmered in infrared. It bounced ultraviolet. It returned radar signals with clean edges. It was open. But all of that changed within a single 48-hour span. Suddenly, the reflected spectrum began to contract. Not dim, not vanish, but narrow. Astronomers call it a spectral bounce, the range of wavelengths that an object reflects back towards sensors after absorbing or scattering incoming light. In natural bodies, this bounce is broad and messy. You get high energy in some bands, low in others, and a chaotic mix determined by surface composition, grain texture, angle of incidence, and atmospheric interference, if any. But now, 3i Atlas was doing something unnatural. The bounce profile began shrinking. Instead of reflecting across dozens of frequency bands, the object began funneling its reflective signature into a tighter and tighter range, until, by early morning on December 10th, it was almost monochromatic. This meant that the object was selectively rejecting most incoming light frequencies and bouncing back only a very narrow slice of the spectrum. And what was more disturbing, that slice was drifting, slowly, deliberately, from blue toward green, then toward a muted amber band. This wasn't a passive reaction to solar exposure. The object had passed similar solar angles before without this behavior. The narrowing happened only after the radiative freeze and the flattening of magnetic interaction. It felt sequential, planned, as if the object was transitioning through phases, each designed to remove a layer of visibility. First, it stopped radiating heat. Then, it dropped its magnetic signature. Now, it was minimizing light return. Every type of energy humans use to study space was being muted, one by one. The ESA's Solar Monitoring Network issued a joint bulletin with the Japanese Hakucho Observatory, noting the same observation. 3. Atlas was no longer responding like a natural reflector. Its spectral response now resembled a tuned surface, something designed to bounce only specific frequencies and cancel the rest. And it wasn't symmetrical. The side of the object still facing away from Earth, now more illuminated by the sun as the object rotated slightly, was still reflecting across multiple bands. But the Earth-facing side was increasingly filtered, controlled, flattened into a single wave band. This suggested directional filtering. Intentional or not, the object was now choosing what light to reflect toward us. That filtering effect made standard spectrographic readings nearly impossible. Labs were forced to switch to high-frequency pulse observation, hoping to capture transient changes through rapid bursts. But even then, the bounce band held tight, unwilling to widen. The implications were chilling. Spectral narrowing is one of the hallmarks of stealth materials. In Earth's aerospace programs, similar behavior is observed in radar-absorbent polymers and coatings applied to experimental aircraft. Technologies designed to confuse sensors by controlling the electromagnetic profile of an object. But this wasn't a test jet. This was an object the size of a mountain, in space, narrowing its signature, reducing its discoverability. The last time a spectral bounce changed this fast, it was on an artificial satellite that deployed shielding to avoid laser detection in low Earth orbit. But now, it was happening on something that came from Jupiter, or beyond. And with each narrowed band, with each layer of energy silenced, Earth's sensors had less to hold on to, less to read, less to understand. It was still coming, still moving toward us, but harder to see and harder to know. Almost as if the object was dimming not for safety, but for secrecy. After the narrowing of the spectral bounce, a new wave of instruments turned their attention to what had always been assumed about 3I Atlas, that it was fundamentally a comet. And comets, no matter how strange their trajectory or how ancient their origin, have one defining trait: they carry ice. That ice, when exposed to the heat of a star, vaporizes, releasing telltale compounds into space: water vapor, carbon dioxide, ammonia, methanol, cyanides, even exotic silicate plumes. These leave signatures, they fluoresce in ultraviolet light, they scatter in the coma, they form tails, they mark a comet as active, decaying, alive. But as 3I Atlas passed deeper into the inner solar system, after grazing Jupiter, after aligning toward Earth, nothing showed up. No water vapor, no volatiles, no ionization trails, nothing that matched any known ice tracer. And this wasn't a small anomaly. It was an absence across every known band. Spectrometers on board the James Webb Space Telescope were the first to raise the alert. As the object approached the 1.3 AU mark, Webb's deep-field infrared scanners detected 0 volatiles. The wavelengths where sublimating gases should appear were flat. No spikes, no rise in reactive signatures, no hydrogen envelope, no tail chemistry. That initial silence was met with skepticism. Had the comet already exhausted its volatiles near Jupiter? Had the radiative freeze altered the emission pattern? But Earth-based arrays confirmed the same conclusion. It wasn't that the tracers were hidden. They were never there to begin with. Even SOFIA, NASA's airborne infrared telescope, swept the upper stratosphere to check for high-angle emission. Nothing. The thermal spectrogram showed no ice sublimation, no molecular breakdown, no trace gases common to carbonaceous or silicate comets. The object wasn't outgassing, it wasn't venting, and it wasn't melting. This presented a problem, because without volatiles, a comet is no longer a comet. It becomes a rock, or a shell, or something designed to move through a star system without reacting to it. That idea struck at the core of comet science. If 3I Atlas wasn't releasing vapor, it either never had it, or it wasn't meant to show it. Some researchers speculated that perhaps the outer shell was so dense, so impervious, that any inner volatiles were trapped beneath a layer of unknown material. But this didn't hold under scrutiny. Even dormant comets with thick outer crusts crack under solar stress. Microfractures form, dust jets erupt, internal pressure pushes upward. Here, there was nothing. No surface vents, no cryovolcanic spikes, no plume shadows. Even as sunlight increased, the outer shell remained inert, and that left only 2 explanations. Either the object never had volatiles to begin with, meaning it's not a comet at all, or it once did, but those materials had been stripped, removed, or never exposed intentionally. That second idea gained traction when linked with the earlier findings. No craters, no heat emission, no magnetic turbulence, and a narrowing light signature. Each layer of behavior suggested control. And if the surface of the object was built, or engineered, to avoid interaction with heat, light, or impact, then shielding the presence of volatiles would simply be another layer of that strategy, not a glitch of nature, but a design decision. A body that emits no gas leaves no trail, and a body with no trail cannot be traced. That was the growing fear, not that we were watching a comet transform, but that we were watching something that was never meant to be a comet in the first place, something wearing the outer shape of a familiar object, but hiding everything else beneath. And now, as it moved closer to Earth, the instruments designed to detect life, decay, heat, and water, all the fingerprints of space as we know it, were returning nothing. Nothing but silence and motion. The Doppler effect has always been one of the most trusted tools in space science. When an object moves toward us, its light shifts toward the blue end of the spectrum. When it moves away, it shifts red. It's how we measure velocity, expansion, distance, approach. And for weeks, 3I Atlas had obeyed the rules. Its inbound trajectory was clean, steady, slightly blue-shifted, as expected for something falling deeper into the sun's well while aligning toward Earth. But then the shift reversed, not gradually, abruptly. Just as telescopes around the world were trying to make sense of its silence, no craters, no outgassing, no spectral volatility. The object did something no comet, no asteroid, no known natural body had ever done. It began returning a red-shifted signal while still moving toward Earth. To most, this seemed impossible. If the object's trajectory was still inbound, and every orbital model confirmed that it was, it should continue to show blue shift characteristics. Every frequency it reflected should be compressed by its motion, not stretched. But the data didn't lie. Spectral sensors from the Atacama Large Millimeter Array in Chile and the Subaru telescope in Hawaii showed identical results. The reflective signature had elongated. The light bouncing back was being stretched as if the object were receding, even though its position was still clearly advancing. At first, analysts thought it could be an error, an atmospheric interference or instrumental artifact, but the effect persisted even in vacuum-based readings from Webb and Hubble. It wasn't a glitch. The Doppler reading had flipped, but the object's direction hadn't. This raised only one possible explanation. The frequency shift wasn't caused by motion. It was being artificially generated. The surface of the object, now known to reject ice, suppress emissions, narrow its spectral bounce, and reflect no heat, was now behaving like a phase manipulator. In simpler terms, it was altering the light it bounced back. Not passively, but actively, like a filter or a frequency-shifting mirror. By doing so, 3I Atlas was broadcasting a false velocity signature. To all sensors, it now appeared to be moving away, when in truth it was still inbound. That revelation sent ripples through the astrophysics community, because this wasn't camouflage. It wasn't just about going dim or silent, it was about deception. In Earth-based military systems, similar principles are used in radar jamming and signal spoofing, reflective decoys that mimic retreating aircraft, pulse distorters that mask true velocity. But to see that happening on an object of this scale, without propulsion, without external heat, without emission, was deeply unsettling. The object wasn't just avoiding detection, it was rewriting how it was detected. No comet does that. No asteroid knows how to mimic a false Doppler shift. And no natural body ever learned to manipulate electromagnetic reflection. But here it was, floating silently, drawing closer, and yet returning the light signature of something pulling away, like a ghost in retreat. That reverse Doppler reading created an even deeper concern. If we can no longer trust the object's light, what else have we misunderstood? Its velocity, its mass, its surface, its internal structure. What if every observation so far had been misread? Not because of error, but because of design. What if this wasn't just an interstellar visitor, but an optical illusion built to pass through our senses unseen? And now, with each passing hour, Earth's instruments were reading the impossible. A red shift that wasn't retreat. An approach masked as departure. And a silence that might not be the absence of sound, but a silence composed. It started as a tremor, so subtle most satellites didn't even flag it. On the morning of December 10th, long-range magnetometers stationed at Lagrange Point 1 began registering a shift. Not a spike, not a surge, but a soft, continuous deviation in magnetic alignment. The type of signal that doesn't scream for attention, only whispers that something nearby is pushing against the invisible fabric surrounding Earth. That push was coming from 3I Atlas. For weeks, the object had travelled silently through the solar system, void of radiation, without heat, without outgassing, and now, with its approach tightening, something changed. Earth's magnetosphere began to bend. The first indication came from the European Space Agency's Cluster 2 satellites. Designed to study the magnetosphere in 3 dimensions, they began picking up a coordinated drift in plasma flow. The flow wasn't chaotic. It wasn't from a solar storm. It was aligned, structured, almost harmonic. It was as if Earth's magnetic shield had suddenly become aware of something foreign nearby. That alone was a warning sign. Normally, only solar flares or coronal mass ejections cause such symmetrical disruption. But this event had no solar origin. The sun was quiet, space weather was calm, and yet Earth's field began to shimmer. By midday, ground-based magnetometers in Greenland and northern Canada picked up identical anomalies, a repeated rhythmic modulation of magnetic pressure, localized in the upper stratosphere, drifting across latitudes, tracking slowly westward. Whatever was causing it wasn't stationary, it was orbiting, moving in tandem with Earth's rotation, and all models pointed to one source, 3I Atlas. This was no longer a distant approach. The object had entered an interactive state. It was now affecting Earth's magnetic shell directly, not through radiation or charged particles, but through field resonance. Magnetohydrodynamic specialists at NASA were among the first to propose the working theory. The object wasn't emitting a magnetic field of its own. It was reflecting or bending ours, like a mirror that doesn't just reflect light, but redirects magnetic flux. This behavior is unheard of in comets. Even metallic asteroids, rich in iron or nickel, cause only brief predictable disturbances when they pass close to Earth. But 3I Atlas wasn't just distorting the field, it was interacting with it, holding it, guiding it. Sensors began to detect a pattern. Every 7 minutes, the amplitude of the disturbance rose, then dipped, rose, then dipped. A pulsed interaction. It mimicked breathing, and it wasn't random. The intervals matched previous pulses observed back when 3I Atlas crossed Jupiter's magnetic line. A perfect recurrence of that earlier rhythm, now echoed in Earth's domain. This suggested memory, or intent. Something on board the object, or within its structure, was reacting to magnetic fields not as a passive object, but as a tuned resonator. By evening, satellite alignment systems began reporting minor disruptions. Navigation drifted by fractions of degrees. This wasn't enough to trigger full recalibration protocols, but it was enough for ground control to notice. The object wasn't even in low Earth orbit, and yet its presence was being felt in the electromagnetic skeleton of the planet. It was touching Earth without touching it. This raised urgent questions. Could the interaction intensify? Was this feedback loop growing? If Earth's magnetic field is the planet's shield, its first layer of defense against solar particles, against radiation, against charged storms, what happens when that field becomes entangled with something we can't see, can't hear, and can't even properly read? Was 3I Atlas learning Earth's shape? Was it mapping the field before final approach? Or was it already locked into some deeper protocol, one that had started at Jupiter and was now entering its final phase here? One thing was certain. Earth's magnetic field had never responded like this before, and whatever 3I Atlas was doing had only just begun. It emerged just after midnight, visible only through stacked composites from telescopes in Chile, Spain, and the southern hemisphere. At first, it looked like noise, an asymmetrical smear on the edge of an otherwise stable image, but within an hour the pattern became unmistakable. 3I Atlas had grown a tail, but not one trailing behind it, one pointing forward. This was the return of the anti-tail, a phenomenon so rare in cometary science that it often divides researchers. In typical comets, the tail forms behind the nucleus, pushed away by solar radiation and the solar wind. The dust particles are lighter than the comet's core, and so they trail like smoke in the wake of motion. But an anti-tail defies this logic. It forms toward the direction of travel, appearing to precede the object as it moves. And this anti-tail wasn't small. It extended for what appeared to be thousands of kilometers from the leading edge of 3I Atlas, forming a narrow structured beam that held steady even as the object rotated, if it was rotating at all anymore. But the real shock came when spectral filters were applied. The anti-tail had no dust signature, None of the particulate markers typically associated with comet tails were present. No silicates, no ionized carbon chains, no trace volatiles. Instead, the beam showed structured reflection across several optical bands, including polarization patterns usually seen in laser diffusion experiments. In other words, it wasn't shedding material, it was emitting a shape. Some suspected it was an illusion caused by geometry. Perhaps the alignment of Earth, the Sun, and the object had created a forward-facing dust illusion, but orbital modelling ruled that out quickly. The angle was too wide, the direction too stable. The anti-tail wasn't an optical trick, it was real. And that meant something else. It was active. For weeks, 3I Atlas had behaved like a dormant shell. No ice outgassing, no cometary trail, no internal heat, no propulsion. But now, this forward-pointing structure indicated a return to activity, though not the kind ever documented before. It didn't behave like a gas vent or particle spray. It behaved like guidance, as if the object were aligning its orientation, shaping the environment in front of it, creating a corridor through which to move. The anti-tail also seemed to affect space around it. High-resolution telescopic footage showed microfluctuations in the surrounding starlight. Not a strong gravitational lensing effect, but something subtler, like a slow shimmer in the background, consistent with electromagnetic wave bending, almost as if the anti-tail was scanning or clearing the path ahead. Some called it a navigation system. Others believed it was a form of energy dispersal, stabilizing local space as it entered Earth's magnetic influence. But a small group of astrophysicists and plasma theorists raised a different possibility. The anti-tail wasn't just reappearing now, it had always been part of 3I Atlas. What if this structure had been dormant, folded into the object's body, invisible to sensors, waiting for activation until proximity with Earth? What if its role wasn't passive at all? The symmetry of the beam, the steadiness of its angle, and its refusal to fragment suggested engineering. This wasn't a trail of decay, it was a projection, and that projection was now stretching across the vacuum, leading 3I Atlas directly into Earth's orbital corridor. Telescopes on the Canary Islands reported something else. The anti-tail seemed to flicker, at a frequency too fast for the human eye, but visible on long exposure frames, like a pulse train, binary flashes, off and on, repeating, not random, not natural, and not from the sun. Something had turned back on, and this time, it was pointing the way forward. Re-examining archival data from 3I Atlas's flyby near Jupiter revealed something that had been overlooked in real time, a faint but unmistakable imprint of the gas giant's radiation belts lingering around the object's trajectory. At first, it seemed impossible. The radiation belts, torrents of charged particles trapped by Jupiter's immense magnetic field, are powerful, energetic, and highly localized. A comet passing through should interact with them, yes, but only temporarily. Usually the passage leaves behind some ionized particles or minor electromagnetic disturbance, and the object continues on its path, essentially unchanged. But 3I Atlas didn't behave normally. Sensors from Juno, which had already recorded minor magnetic disturbances during the flyby, now showed something subtle yet persistent. Traces of ionized sulfur and oxygen, typical constituents of the inner radiation belts, were detected along the object's tail path. It wasn't just debris being stripped from the belts. It was a faint signature of capture, absorption, and perhaps internalization. This suggested that 3I Atlas had interacted with the radiation in a way no natural body could. A comet passes through belts and continues, battered but unchanged. But this interstellar visitor appeared to have collected the energy in some fashion, preserving it internally. The detection was confirmed independently by both Hubble and the Very Large Array, each observing subtle ultraviolet and radio emissions from particles in the vicinity of 3I Atlas. They were consistent with an object that had moved through Jupiter's magnetosphere and retained a memory of that environment. Not just a passive imprint, but something active. The emission pattern suggested storage and regulated release, not random dispersal. This raised immediate questions. Could 3I Atlas be harnessing magnetic energy, much like a spacecraft would? Could the object's ability to survive close solar passes, maintain perfect surface integrity, and execute precise orientation maneuvers be connected to this magnetic interaction? The patterns suggested more than coincidence. They hinted at design, or at least something previously unseen in natural interstellar objects. Further modelling suggested an intriguing mechanism. By passing through the most intense zones of Jupiter's radiation belts, the object could induce current flows within conductive material inside its structure. These flows could then be stored, used to stabilize rotation, or even redistribute energy across the surface. It would explain the sudden thermal uniformity, the reflective increase, and the precise anti-tail behavior observed after the flyby. Even more compelling was timing. The pulse detected in the belts correlated almost perfectly with the initial Doppler anomalies recorded as the object approached Earth. The sequence implied that energy from Jupiter had been captured and perhaps deliberately integrated into the object's systems, providing it with the power needed to execute complex maneuvers with no visible propulsion. In short, 3I Atlas didn't merely survive Jupiter, it leveraged the encounter. If this was intentional, then the object had been prepared long before reaching our solar system. The radiation belts, dangerous to nearly every spacecraft humanity has sent, had become an energy source for the interstellar traveller. A natural hazard turned into an advantage. By the time it had exited Jupiter's sphere of influence, Earthbound sensors began detecting the first subtle indications of its next phase: orientation toward our planet, a cessation of tumbling, and the emergence of its anti-tail structure. Every subsequent anomaly, thermal freeze, spectral narrowing, Doppler reversal, now made sense in the context of energy harnessed during that flyby. In essence, Jupiter had left an imprint, not a scar, not debris, but a stored usable signature embedded within 3I Atlas, a silent memory of magnetic power, ready to manifest as the object approached Earth's domain. And that realization sent a chill through the scientific community. The object wasn't just passing by, it had been charging, preparing, and now entering its final, most critical stage of activity. As the observations continued on the morning of December the 10th, a subtle but unmistakable pattern emerged along 3I Atlas's structure. Using high-resolution imaging from multiple observatories, Chile, Hawaii, and the Canary Islands, the team began noticing a faint luminosity along the tail, forming an arc of light. Not irregular, not broken, not scattered, but perfectly curved, extending across the leading edge of the tail, for hundreds of kilometers. Initially, astronomers assumed it was an optical artifact, a lensing effect caused by sunlight striking the particle stream at an unusual angle. But careful cross-validation quickly ruled that out. The arc persisted across multiple instruments, angles, and spectral bands. Even under near-ultraviolet and infrared filters, it remained consistent. It wasn't a visual fluke, it was a structural feature. This was no ordinary cometary phenomenon. Comet tails rarely, if ever, hold a perfect geometric form. Solar winds bend dust and gas chaotically. Jets fragment unpredictably. Even anti-tails, while rare, exhibit irregularities dictated by particle mass and solar pressure. But this arc maintained near-flawless curvature, symmetrical along the object's central axis, and remained stable as 3I Atlas rotated minutely while progressing toward Earth. Spectral analysis revealed something even stranger. Unlike typical comet material, the arc was not composed of volatile gases or ice particles. There was no detectable water vapor, carbon monoxide, or cyanide trace. Instead, the emission consisted of highly reflective fine particles, almost like crystalline dust, but unusually uniform. Each segment of the arc reflected light with consistent intensity, suggesting either an internal stabilization mechanism or an artificial structuring of material. Magnetometer data offered additional insights. While the arc itself produced no measurable field, subtle distortions were observed in the surrounding plasma. Charged particles in proximity were slightly diverted along the curve, implying that the arc was not merely passive dust but potentially interacting with local electromagnetic conditions. The effect was weak, almost imperceptible, yet consistent across the observable length of the emission. Simulations attempted to replicate the phenomenon. Standard comet models failed. Gas and dust particles always fragmented or spread under solar wind influence. Only when a controlled, energy-managing surface was introduced in the models did the curve stabilize, implying that 3I Atlas itself was actively maintaining the arc, either through internal mechanisms or precise orientation of ejected matter. It was as if the object was sculpting its own tail in real time. Even more compelling was timing. The formation of the arc coincided with the moments after the object's antitail reappeared, and the spectral bounce narrowed. The sequence suggested coordination, reflective surface adjustments, directional emission, and selective particle control. Each anomaly was building toward a coherent pattern, forming a system of effects that appeared deliberate rather than incidental. Some theorists proposed that the arc could function as a guide, a visual or electromagnetic signaling system, or perhaps a field shaping the surrounding space for navigation. Others suggested it might act to disperse radiation or control internal heat flow. Whatever its function, the precision implied intelligence, not randomness. Finally, the curvature of the arc mirrored the object's alignment toward Earth. It was as though 3i Atlas were tracing a subtle, invisible path, highlighting its trajectory while simultaneously preparing for interactions with Earth's magnetosphere. The symmetry and persistence of the emission suggested active monitoring of environmental conditions and continuous adjustment, a behavior far beyond any natural interstellar body ever observed. For the first time, researchers were forced to consider the implications seriously. This emission arc was not a cometary tale. It was a controlled phenomenon, an extension of 3i Atlas's activity as it approached our planet. And while small and faint, its perfection hinted at the level of precision this object could exercise, an unsettling glimpse of its potential as it continued on its trajectory toward Earth. For any object moving through space, especially one of the size and scale of 3i Atlas, acceleration comes with a signature. Even the smallest changes in velocity create micro-torques. Even minor directional adjustments cause minute wobbling detectable by precision instruments. Space is never perfectly frictionless. Interactions with solar wind, radiation pressure, and particle impacts ensure that no body moves entirely without disturbance. Yet, as 3i Atlas approached Earth's orbital region, a baffling anomaly appeared. There was no acceleration noise. High-sensitivity radar and optical tracking, conducted simultaneously by observatories in Chile, Arizona, and the Canary Islands, confirmed the readings. While the object exhibited subtle course adjustments, sufficient to refine its approach trajectory, none of the expected disturbances in spin, wobble, or vibration were detectable. No measurable deviation in angular momentum, no micro-vibrations in rotation, nothing. This was impossible for a natural object. Even spacecraft with sophisticated stabilization systems exhibit residual torque and reaction mass irregularities. A natural interstellar object, shaped irregularly and composed of uneven mass distributions, should tumble or jitter under any form of propulsion or directional shift. Yet here, 3i Atlas was moving with absolute smoothness, every rotation minute, every adjustment silent and imperceptible. Scientists began to calculate the improbability. Based on size estimates, mass distribution, and previous acceleration events, every simulation predicted tiny, unavoidable perturbations. Observed velocity changes should have produced detectable microtorque. They didn't, not one. The object's motion suggested an internal system of stabilization, something capable of countering environmental forces with extraordinary precision. The kind of system used on interstellar probes designed to maintain exact orientation while conserving momentum. But 3i Atlas had no visible propulsion, no discernible exhaust, no interaction detectable by the full array of electromagnetic, infrared, or radar instruments. The object's lack of acceleration noise also explained some of the prior anomalies. The thermal equalization, the spectral narrowing, and the emission arc all required fine control over orientation and movement. Maintaining such precision without producing detectable torque is a feat that natural physics cannot account for under current understanding. Researchers considered alternative explanations. Could the object's material composition somehow absorb or counteract momentum changes? Perhaps an exotic internal lattice or a non-uniform density profile could dampen wobble. Theoretical models suggested that only materials far denser and more conductive than any known comet could achieve this. That would require conditions or construction unlikely in naturally occurring interstellar objects. The implications were chilling. This was not merely a passive object drifting through the solar system. Every movement, every adjustment was perfectly managed. It had trajectory, orientation, and rotation control beyond any naturally observed mechanism. It wasn't subject to the chaotic forces of space. It was dictating its own interaction with them. Furthermore, The precision allowed 3i Atlas to execute maneuvers without leaving detectable trails. This accounted for the lack of dust ejection, the absence of thermal disturbances, and the clean emission arc observed days earlier. The object was moving deliberately, yet entirely silently. It became increasingly clear that 3i Atlas was operating according to rules that humanity had never observed in a natural celestial body. No comet, asteroid, or interstellar fragment moves through space with such undetectable precision. Every feature, no craters, no outgassing, no acceleration noise, pointed to one conclusion. The object was engineered to manage its own motion flawlessly. And now, approaching Earth's magnetic domain, the implications of that control were even more profound. Without acceleration noise, it could interact with planetary fields, radiation environments, and solar flux without perturbing its trajectory or revealing its true intent. Its approach was silent, calculated, and unnervingly exact. For the first time, observers could no longer treat 3i Atlas as merely an interstellar visitor. It was something else entirely, a moving entity capable of precise, undetectable manipulation across millions of kilometers of space. And as it drew closer, that silent mastery over motion left the scientific community with a chilling question. If it could move this perfectly unseen, what else could it do next? As 3i Atlas edged closer toward Earth's orbital path, instruments designed to measure gravitational anomalies began detecting subtle distortions in the space surrounding it. Initially, these were dismissed as noise from the combined interference of solar radiation, the Moon's orbit, and minor satellite clutter. But as the hours passed, the pattern became clear. The object was influencing the flow of light and radiation in a manner consistent with gravitational lensing. Gravitational lensing occurs when a massive object bends the path of light travelling nearby, focusing it like a magnifying lens. Usually this is observed with stars, galaxies, or black holes, objects of immense mass. Earth itself, though far smaller, has a detectable lensing effect for certain precise experiments using satellites and ground-based lasers. Typically, however, the influence is minor, requiring nanometer-level precision to measure, and rarely producing immediate observable effects on passing interstellar objects. Yet, 3i Atlas had entered the zone where Earth's subtle lensing could interact with its trajectory. High-resolution laser interferometry performed by the European Southern Observatory detected a bending of photons along the object's projected path. Not random bending caused by solar flares or interplanetary dust, but a consistent directional distortion aligned with the Earth-facing hemisphere of the object. What made this extraordinary wasn't the lensing itself, it was how 3i Atlas responded. As the object moved through Earth's gravitational influence, the arc of light surrounding it, already noted in previous observations, appeared to stabilize further. Minor irregularities flattened. The forward emission arc, visible even through optical filters, followed a smooth curvature that perfectly matched the local gravitational gradient. It was as if the object were using Earth's gravity to guide its own optical signature, shaping the arc to maintain coherence and stability. Satellites in low Earth orbit picked up subtle alignment shifts. Photons reflected from nearby atmospheric particles deviated slightly from predicted paths. Radar echoes bounced back with minimal scatter, even as the object moved through the solar wind's variable plasma. The combination of gravitational and electromagnetic effects suggested that 3i Atlas was not only aware of Earth's lensing influence, it was interacting with it deliberately, using the gravitational environment to enhance stability and refine orientation. Computer simulations ran in parallel confirmed the anomaly. When modelled as a passive object, 3i Atlas's path produced minor uneven distortions in the light signature, but when modelled as an active system capable of subtly redirecting photons and stabilizing its reflective arc in response to Earth's gravity, the observed data matched perfectly. The simulations implied a feedback loop. Real-time environmental sensing translated into minor structural or surface adjustments, maintaining the perfect curvature of the emission arc. This raised profound questions. Could the object be actively manipulating light through gravitational amplification? Was the arc itself a tool for observation, signaling, or navigation? If so, the sophistication of the interaction suggested not random, natural forces, but an advanced form of control far beyond anything humanity had previously documented in interstellar objects. The timing also aligned with previous anomalies: the radiative freeze, Doppler shift reversal, and spectral narrowing. Together, they formed a sequence of escalating interactions, first suppressing signature, then redirecting light, and now leveraging Earth's gravitational field to maintain precision. Observers on Earth remained in quiet astonishment. While the gravitational effects were small, the fact that a single object could synchronize multiple environmental factors — solar, magnetic, thermal, and now gravitational — was unprecedented. This was no longer a passive interstellar body. It was a system capable of sensing, responding, and adapting to its surroundings at extraordinary levels of precision. For the first time, the notion that 3I Atlas might be actively aware of planetary environments gained credibility. And as the object continued along its trajectory, the interplay between its emission arc and Earth's gravity lensing hinted at one inevitable conclusion. Whatever 3I Atlas was planning, it had already begun preparing the stage. As 3I Atlas entered Earth's gravitational domain, instruments across the globe began detecting a familiar yet increasingly eerie phenomenon. The polar pulse had returned. This was a signal pattern first observed during the object's approach to Jupiter, faint but measurable, aligning with its rotation and axial orientation. Now, as it neared Earth, the same rhythm re-emerged, but more pronounced and unmistakably directed. The first detections came from high-latitude magnetometers in Canada and Greenland, followed quickly by European arrays monitoring auroral activity. Unlike previous signals which had appeared sporadically and faintly, this pulse now registered consistently across multiple stations. Its interval, roughly 7 minutes, matched the rotational period inferred from optical measurements. Yet, unlike a typical magnetic oscillation induced by a moving body, this pulse was highly directional, strongest along the Earth-facing axis of the object. Simultaneous observations from ESA's Cluster 2 satellites revealed that the pulse caused subtle, rhythmic distortions in Earth's magnetosphere. These distortions were minor, easily overlooked without precise instruments, but remarkably coherent. Plasma flow lines bent slightly in response, following the rhythm of the pulse. The energy did not appear destructive, nor did it interfere with communication systems. Instead, it suggested a controlled modulation, a steady heartbeat synchronized with the object's rotation. This raised immediate questions. How could a body so far away moving through the vacuum of space produce a pattern so precise that it aligned with a planetary magnetosphere thousands of kilometers distant? Standard physics could not account for it. Even metallic asteroids known to induce magnetic anomalies create irregular, unpredictable signals scattered by distance and field interactions. 3I Atlas, by contrast, produced perfectly timed directional oscillations as if actively probing the environment. Spectroscopic measurements provided additional clues. The pulse correlated with minor variations in the object's infrared and optical emissions. Not full flares, not spikes, but subtle modulations, light intensity increasing and decreasing in tandem with the magnetic pulse. This suggested that the object's surface, its reflective arcs, and perhaps internal structures were responding dynamically, adjusting to maximize the effect. It was no longer passive. It was actively modulating multiple aspects of its physical presence in real time. Modeling teams at NASA Ames and the European Space Operations Centre began exploring the possibility that the polar pulse served as a feedback mechanism. By emitting energy or guiding reflected light in a specific rhythm, 3I Atlas could measure environmental responses from nearby magnetospheres. The pulse's consistency and synchronization with rotation implied a sensor-driven process. The object could detect field strength, orientation, and perhaps even subtle electromagnetic currents, then adjust its own behavior accordingly. The timing was equally significant. The return of the polar pulse occurred immediately after the emission arc formed a perfect curve and the spectral bounce narrowed. Together, these anomalies formed a sequence of escalating interactions. First, reducing detectable signals, then controlling reflected light, now interacting magnetically with a planetary field. Each step appeared deliberate, forming a coordinated system of environmental engagement. For the first time, it became clear that 3i Atlas was not simply moving toward Earth. It was actively engaging with its surroundings, sensing, adjusting, and maintaining control across multiple domains. Magnetic, optical, and possibly thermal feedback were integrated into a single, coherent process, executed without detectable acceleration noise, debris, or thermal irregularity. The return of the polar pulse also reinforced a disturbing possibility. 3i Atlas was aware, if not conscious in a human sense, then in the sense of responsive environmental manipulation. Its interactions were not random. They were calibrated, timed, and coordinated to maximize effect while remaining nearly undetectable. And as the pulse continued its rhythmic beat, a silent realization spread through the scientific teams monitoring the object. Whatever 3i Atlas had learned from Jupiter, whatever energy it had stored and whatever patterns it had developed, it was now using all of that information in real time. Earth was no longer a passive observer, we were part of the system. The heartbeat of the polar pulse pulsed steadily, guiding attention, energy, and observation. It was subtle, beautiful, and terrifying, all at once. As 3i Atlas continued its silent approach along Earth's orbital path, thermal instruments scanned for traces of its passage. Normally, an object of its size and activity would leave a detectable wake, a trail of heat in the surrounding plasma, or residual infrared emissions in the thin dust and gas of interplanetary space. Even relatively small asteroids produce thermal signatures that can be traced over thousands of kilometers. Comets, when active, create extensive heat trails from sublimation and jet activity, yet 3i Atlas produced none. From the moment its reflective arcs and polar pulses were observed, high-resolution infrared arrays noted something extraordinary. The thermal field behind the object remained unchanged. Despite emissions observed in the anti-tail, despite pulses interacting with Earth's magnetic domain, the space immediately trailing 3i Atlas showed no detectable rise in temperature, no radiative footprint, no dispersion of energy, a perfect void. Observatories from the European Space Agency and NASA collaborated to confirm the observation. Webb, Hubble, and Sophia, all independently, reported identical results. In every spectral band capable of detecting residual heat, the wake was invisible. Where models predicted a plume of radiative energy, or even a faint trail of thermal turbulence, instruments detected nothing. This absence was not passive. It wasn't a matter of distance or cooling over time. The lack of a thermal wake was observed concurrently with other anomalies: the narrowed spectral bounce, the perfect curvature of the emission arc, and the active polar pulses. Together, they suggested that 3i Atlas was not just avoiding emission, it was actively controlling the environment around it, suppressing heat and stabilizing the surrounding plasma. Researchers proposed several possibilities. One hypothesis suggested a thermal containment field, an advanced mechanism that captures, redirects, or absorbs the object's radiated energy before it can escape into space. Such a system would allow 3i Atlas to adjust temperature, maintain surface uniformity, and prevent a detectable wake, effectively hiding the energy it uses to maneuver. Another theory posited that the object's composition plays a role. Certain dense, conductive, or reflective materials could naturally redistribute energy across the surface or internally, preventing leakage into the surrounding environment. But while plausible for small-scale phenomena, the scale and precision observed in 3i Atlas exceeded any natural explanation. No known material could suppress heat so completely, while sustaining active emissions and orientation control. The implications extended further. A lack of thermal wake meant that traditional detection methods, infrared, Doppler thermal tracking, and residual radiation mapping, were largely ineffective. The object could execute maneuvers, adjust trajectory, and maintain orientation without leaving traces, rendering typical monitoring techniques unreliable. This added a level of uncertainty to predictions about its future path, particularly as it approached Earth's magnetic influence and orbital domain. Beyond observation, the phenomenon suggested an extraordinary level of internal control. The object could actively manage not only light and magnetic interactions, but also the thermal energy it produced, maintaining perfect balance while moving at high velocity. Combined with the polar pulses and emission arcs, this lack of thermal signature reinforced the idea of a fully integrated, highly responsive system, operating across multiple physical domains simultaneously. For scientists, the message was clear. 3I Atlas was no ordinary interstellar object. It was a self-regulating, precise, and extraordinarily efficient entity. It moved through space without leaving a footprint, interacted with planetary fields, and managed energy to avoid detection. And as it glided toward Earth, the absence of a thermal wake was yet another reminder of its advanced and deliberate design. In the silent void behind it, where heat should have lingered, there was nothing. A void that spoke volumes. 3I Atlas had mastered the art of moving unseen, leaving only its intentional signals, polar pulses, emission arcs, and perfectly aligned orientation as evidence of its passage. As 3I Atlas continued its approach toward Earth's orbital corridor, a perplexing new phenomenon appeared. The object's tail, already remarkable for its anti-tail and perfectly curved emission arc, began to expand, spreading outward at a rate inconsistent with any previously observed comet or asteroid. Yet, there was one key anomaly. The expansion occurred without any detectable venting from the core. Normally, a tail forms as a consequence of material ejected from the nucleus. Ice sublimates, volatile gases escape, dust follows, and the solar wind pushes this mass outward. Expansion is a direct result of these processes. The tail reflects the core's activity. But 3I Atlas broke that paradigm. High-resolution imaging from the European Southern Observatory showed the tail widening symmetrically, its edges sharp and consistent, yet there was no corresponding increase in core emissions, no evidence of heat flux, no particle dispersal detectable in any band. The first teams to notice this were in Chile. Using the VLT's high-magnification instruments, they measured the tail's width increasing at a predictable rate, maintaining the perfect curvature aligned with the Earth-facing axis. The outer edges remained coherent, and no debris trail was observed behind the expansion. Simultaneously, infrared arrays confirmed the core remained thermally stable, reinforcing the notion that the tail's growth was decoupled from conventional energy sources. Researchers then turned to spectrographic analysis. The expanding tail showed reflective properties consistent with the object's surface particles, yet no trace of outgassed material. No water vapor, carbon monoxide, or other volatiles was detected. In other words, the tail behaved as if it were an independent structure, not a byproduct of nucleus activity. Its motion suggested deliberate shaping, maintaining uniform density and alignment without compromising the tail's smooth curvature. Some theorists suggested magnetic or electrostatic forces might be at play. The object could be using subtle electromagnetic manipulation to lift and direct fine particles from its surface into a structured tail, controlling expansion without releasing mass in a traditional sense. This would explain the absence of core venting while maintaining coherence. Simulations indicated that if the object had conductive or responsive surface materials, it could indeed generate enough localized force to sustain the observed tail expansion, even in the vacuum of space. Additionally, the tail's growth seemed synchronized with Earth-facing orientation. Observations showed that as 3I Atlas adjusted its axis to track Earth, the tail expanded more rapidly along the side aligned with our planet, while maintaining symmetry across the perpendicular axis. This suggested an environmental interaction, possibly using gravitational or magnetic gradients, or even solar radiation pressure, in a manner highly controlled by the object itself. It was a subtle form of manipulation that natural bodies are incapable of achieving at this scale. The absence of core venting combined with precise expansion and alignment pointed toward one conclusion. 3I Atlas was executing active, non-destructive structural control of its tail. It was not passively reacting to solar wind or gravitational forces, it was orchestrating the expansion intentionally. The object's tail had become not merely a visual signature, but a functional extension of the object itself, responsive to orientation, environment, and perhaps even observation. For observers on Earth, the implication was profound. The tail's expansion without core activity reinforced the cumulative evidence. 3I Atlas was not a comet. It was a system, engineered, self-regulating, and capable of complex interactions across multiple domains simultaneously. Its movements, emissions, and now tail behavior all pointed toward intentional, controlled phenomena, leaving humanity to confront an object whose behavior defied every natural expectation. In essence, the tail had grown without a sound, a flicker, or a particle expelled from the core. It expanded silently, precisely, and deliberately, a testament to the object's extraordinary mastery over its own presence in space. As the monitoring of 3I Atlas progressed, scientists turned to computational modeling to predict its trajectory and behavior. Multiple agencies, NASA, ESA, JAXA, and independent university teams, fed observational data into advanced AI systems designed to simulate interstellar objects' motion. Normally, such models produce highly consistent projections, with minor variations accounted for by environmental uncertainty. But with 3I Atlas, something unprecedented occurred. The datasets began diverging. At first, the differences were subtle. AI models trained on optical tracking data predicted slightly different orbital arcs than those using infrared or radar-derived datasets. Minor deviations could have been dismissed as measurement noise, yet as hours passed and more observational inputs were added, magnetometer readings, polar pulse timings, tail morphology, the discrepancies grew. One model predicted a subtle rotation around a vertical axis. Another suggested near-perfect stabilization. A third implied a slight lateral drift in the trajectory, inconsistent with gravitational forces alone. The divergence wasn't random, it was systemic. Each AI system had been designed to reconcile observational inputs and output a statistically most probable path. The fact that they were producing inconsistent projections indicated that the input data itself was non-deterministic. In other words, 3I Atlas was feeding the model's contradictory signals. The question arose, why would a celestial object generate data that undermines predictive systems? Initially, some scientists suggested interference, anomalous sensor readings, or environmental noise. But cross-validation with independent instruments confirmed the effect. Every sensor array, optical, infrared, radar, and magnetometer, provided internally consistent data. The divergence emerged only when this data was integrated into predictive models. The implication was chilling. 3I Atlas was producing measurements that behaved differently depending on observational context. AI algorithms designed to simulate conventional physics could not reconcile the behaviors into a single coherent projection. The object's observed position, rotation, emission patterns, and tail structure interacted in ways that contradicted conventional physical models. Each dataset told a slightly different story about the object's behavior, as if it had multiple simultaneous states. Modeling teams began treating this divergence not as an error, but as a feature. By examining which aspects of the datasets were inconsistent, they could identify the parameters being manipulated or hidden. Velocity, spin, tail expansion, thermal output, and spectral reflection all appeared to vary slightly depending on observational angle or sensor type. In effect, the object's environment, the act of observing it, was influencing the data. The divergence became more pronounced after the polar pulse resumed, and the anti-tail expanded. AI projections relying on previous assumptions about rotational inertia or thermal output failed entirely. The only models that maintained predictive consistency required accounting for active feedback mechanisms within the object itself. Systems capable of sensing environmental inputs and adjusting emission, reflection, or motion in real time. This meant that 3E Atlas was, in effect, responding to being observed, and doing so in a way that confounded even advanced predictive algorithms. Scientists realized that conventional predictive modeling might never fully capture the object's behavior. Each AI dataset represented a limited perspective, constrained by the physics encoded in the model. 3I Atlas, however, operated outside these constraints, forcing each model to diverge based on the data it received. In a sense, the object had become a moving, adaptive puzzle, feeding Earth's systems information that was accurate yet incomplete. The divergence highlighted an important truth. Predicting the next moves of 3I Atlas would require more than observation. It required understanding the rules the object itself was following, a set of behaviors that combined precision, environmental awareness, and deliberate modulation. Until that framework could be deduced, every dataset remained partially contradictory, every projection uncertain, and every prediction speculative. In short, humanity had entered a phase where the object was not merely moving through space. It was interacting with knowledge itself, challenging the AI systems designed to anticipate its path and asserting control over how it could be understood. As 3I Atlas progressed along its trajectory, optical instruments began recording a peculiar synchronization between the object's brightness and Earth's position. Initially, the effect was subtle, small fluctuations in reflected light that seemed random, but as more data accumulated, a pattern emerged. The object's albedo increased predictably whenever Earth moved into the line of sight of its forward-facing hemisphere, then decreased slightly as Earth rotated out of alignment. High-resolution photometry from multiple ground-based observatories, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii, confirmed this correlation. Even long-exposure imaging showed that the luminous intensity of 3I Atlas was not uniform or passive. Instead, it varied systematically in response to Earth's orbital position, almost as if the object were aware of where it was being observed from. This phenomenon was unprecedented. Natural interstellar bodies do not adjust their reflective properties based on the position of a planet. Even the most reflective asteroids show variations due to rotation, surface composition, or phase angle. But these are dictated by geometry and orientation relative to the Sun, not a distant observer. In contrast, 3I Atlas demonstrated a direct feedback loop. Earth's position influenced its apparent brightness. The timing was precise. Each fluctuation coincided with calculated positional intervals derived from satellite tracking data. The increase in brightness was most notable when Earth crossed the central axis of the object's emission arc. As Earth moved away from this axis, reflectivity dropped. The modulation was gradual but deliberate, suggesting control rather than coincidence. Spectroscopic analysis added another layer of mystery. The reflected light during these brightening events was not only intensified, but also slightly shifted in wavelength. The dominant reflection moved towards shorter wavelengths, producing a subtle blue tint. This spectral adjustment appeared coordinated with the light modulation itself, enhancing the effect of alignment with Earth. In essence, 3I Atlas was tuning its reflectivity and spectrum to maximize its signature precisely when it faced our planet. Researchers proposed several hypotheses. One suggested an active surface capable of dynamically adjusting reflective properties. Another theorized that the object might be using internal mechanisms to direct or amplify light toward Earth's position. A third, more speculative theory considered that the object was employing a form of environmental sensing, detecting the relative position of Earth through subtle gravitational or magnetic interactions and responding accordingly. Regardless of mechanism, the result was consistent. 3I Atlas was now interacting with Earth in a way that affected how it could be observed. The effect was strong enough that astronomers could predict brightness increases with high confidence based solely on Earth's trajectory. No natural interstellar body had ever demonstrated this level of coordination between observer and object. The implications were profound. If 3I Atlas could modulate its apparent brightness in response to Earth's location, it indicated a level of environmental awareness and precise control previously unseen. Combined with earlier anomalies, anti-tail formation, emission arcs, polar pulses, and Doppler manipulation, the brightness response reinforced the growing consensus that 3I Atlas was not a passive interstellar object, but an active system capable of interacting with its surroundings intentionally. Moreover, the brightness modulation provided indirect evidence of internal energy management. The surface or emission arc had to be capable of adjusting reflectivity without creating detectable acceleration noise, thermal spikes, or particle emission. This aligned with prior observations of thermal stabilization and tail expansion, without core venting, suggesting a fully integrated system capable of sensing, processing, and responding in real time. For Earthbound observers, the phenomenon was both fascinating and unsettling. 3I Atlas was no longer simply a visitor in the solar system. It was actively engaging with the planet, reflecting not only sunlight but, seemingly, a form of awareness. Every fluctuation in brightness became a signal, a trace of intent, and a reminder that the object's approach was not entirely natural. As its luminosity shifted with each passing hour, astronomers could not help but feel that 3I Atlas was guiding its own observation, choosing when to shine, when to hide, and precisely how to present itself to the world watching from below. As 3I Atlas continued its approach toward Earth, an entirely unexpected observation emerged. During high-speed imaging sequences captured simultaneously by multiple observatories, Chile, Hawaii, and the Canary Islands, researchers noted fleeting appearances of small secondary objects moving in tight formation near the main body. At first, these were dismissed as lens flares, cosmic rays striking detectors, or satellite interference. But repeated observations, confirmed across independent instruments and spectral bands, indicated something far stranger. The secondary objects were real, and they were behaving in an unusually coordinated manner. These transient companions appeared for only brief intervals, sometimes a few seconds, occasionally stretching to a minute, but always in the same region relative to the primary body. They followed the same general trajectory as 3I Atlas, yet each exhibited subtle, deliberate motion, small oscillations, tight curves, and synchronization with the primary's rotation and emission arcs. Their appearances were not random, they seemed tied to the main object's behavior. Spectral analysis suggested these secondary objects were reflective, but unlike the primary body, they emitted faint infrared signatures, indicating they might be composed of a different material or a thinner, more reactive surface. Still, no evidence of outgassing or debris was detected. They were not breaking off from the primary, nor were they ejecta in the conventional sense. Instead, they behaved as discrete entities, briefly visible, then seemingly vanishing into space. Astronomers struggled to explain this phenomenon. Natural interstellar objects do not generate transient companions. Fragmentation produces debris fields or predictable asteroid-like fragments, which remain detectable over long periods. These secondary objects did not behave that way. They appeared to materialize and dematerialize, at times aligned with the emission arcs, anti-tail, and polar pulse of the main body. Their timing correlated with the brightest phase of the main object's reflective modulation, further reinforcing the connection. One hypothesis considered by the European Southern Observatory team proposed optical interference patterns, an unusual scattering of light around the highly reflective surface of 3I Atlas. However, the effect persisted even when observed from different angles, wavelengths, and instruments, ruling out a purely optical explanation. Instead, it suggested that the secondary objects had physical presence, albeit transient. Another speculative theory posited that 3I Atlas might be deploying or projecting small, controlled masses to manipulate the surrounding space. These could act as miniature field markers, optical decoys, or even environmental probes. The consistency in their motion relative to the main body implied precise control, possibly using electromagnetic, gravitational, or other force interactions to maintain position and coordination. Despite their brief appearances, the secondary objects introduced a profound challenge to existing models. Every simulation of 3I Atlas that treated it as a single body now failed to account for these transient companions. Predictive algorithms diverged dramatically, and AI-based trajectory models could not reconcile the sudden appearance and disappearance of small nearby bodies with expected gravitational and inertial behavior. Observers noted one final curious pattern. The secondary objects always appeared along the projected path of the emission arc, maintaining alignment with the curvature of the tail and pointing toward Earth. They were not trailing in the antitail nor preceding it. They appeared in the space immediately adjacent to the luminous structure, as if reinforcing or interacting with it. In essence, 3I Atlas was no longer a solitary object. It had become a dynamic system, a primary body capable of manifesting secondary elements that could operate independently, yet in perfect harmony with its own structure. Each brief apparition suggested intelligence, environmental awareness, and an ability to manipulate the surrounding region with precision. For scientists on Earth, the phenomenon was both fascinating and alarming. These secondary objects confirmed that 3I Atlas was not a simple interstellar visitor. It was a coordinated, adaptive system, actively engaging with its environment, capable of projecting influence beyond its visible form and challenging every known model of natural celestial mechanics. As 3I Atlas approached deeper into the inner solar system, radar observations revealed a startling anomaly. Its radar cross-section, the measure of how detectable an object is via radar, had suddenly tripled. For an object of its size and previously known properties, this increase was extraordinary, and it could not be explained by rotation, orientation, or surface reflection alone. The first indication came from the Goldstone Solar System radar in California. Operators noted unusually strong returns during routine tracking, Signals that had been consistent for weeks suddenly amplified, producing reflections far larger than expected. The object's apparent size in radar imagery had not physically changed, yet the return signal suggested a surface area many times greater than previously measured. Subsequent verification by Arecibo's archived radar systems and European radar arrays confirmed the phenomenon. The effect was real. Initial hypotheses considered the possibility of debris or a gas plume suddenly emerging from the nucleus. In standard comets, outgassing can increase radar reflectivity by scattering electromagnetic waves. Yet, in this case, infrared, optical, and spectral observations showed no new emissions. There was no venting, no tail expansion, no increase in surface particles. The cross-section change could not be explained by classical cometry activity. Analysts then examined orientation effects. 3i Atlas had recently stabilized its axis toward Earth, minimizing tumbling and rotational noise. Could this alignment alone account for the increased radar return? Calculations indicated a modest enhancement, perhaps 20 to 30%, but nowhere near the tripling observed. The magnitude of the increase required an additional factor. A deeper investigation suggested a structural explanation. The radar reflection appeared to encompass a larger effective surface than the visible geometry indicated. Essentially, the object's radar signature was no longer a simple echo of its physical dimensions. Instead, it acted as though the object had extended or projected a reflective field, capable of bouncing radar waves from a broader area. This correlated with previous observations of the emission arc and the secondary objects, hinting at a coordinated system capable of modulating radar reflectivity. The precise mechanism remained speculative. One possibility involved an advanced surface configuration, dynamically adjusting electromagnetic properties to amplify return selectively. Another considered that the object's surrounding region, previously assumed to be empty space, contained a faint electromagnetic envelope, invisible to optical instruments but highly reflective to radar. Either explanation implied a level of environmental manipulation unprecedented in known natural objects. The timing of the increase was also significant. The cross-section tripling coincided with Earth crossing the line of the object's emission arc and the active polar pulse rhythm. This synchronicity suggested that the radar enhancement was not random. Instead, it appeared responsive, linked to Earth's position and potentially serving as a deliberate signal or observational effect. For planetary defense teams, the implications were both intriguing and concerning. A larger radar cross-section improves detectability for tracking, yet the mechanism by which 3i Atlas achieved this remains unknown. If the object could amplify radar returns at will, it might also manipulate other electromagnetic observations, complicating predictions and monitoring. From a scientific perspective, the tripling of radar cross-section confirmed a broader pattern. 3i Atlas was not a passive interstellar body. Every new observation, from tail dynamics to thermal stabilization, spectral narrowing and polar pulses, pointed to active control over its interaction with physical and electromagnetic environments. The radar anomaly was another clear indicator that this was a system operating far beyond natural cometry behavior. In essence, 3i Atlas had demonstrated a capability to reshape how it appears to instruments on Earth, not by changing physically, but by controlling the signals it returns. Its approach was no longer just a passage through the solar system. It was a carefully modulated, observable performance, one that left scientists rethinking everything known about interstellar objects. As 3i Atlas continued its steady approach, a new observational anomaly became apparent in the ultra-low frequency ULF band, the range typically monitored for planetary and interplanetary electromagnetic activity. These frequencies, often between fractions of a hertz and a few hertz, are sensitive to natural interactions between objects and the surrounding plasma, including induced currents, magnetic field perturbations, and solar wind modulation. For a body of 3i Atlas's scale, some ULF interaction was expected. Yet, as data streamed in from Earth-based magnetometers, satellites, and high-altitude observatories, the results were stark. The ULF band remained unnaturally quiet. This silence was measured across multiple stations simultaneously. Ground-based arrays in North America, Europe, and Asia reported baseline readings that remained constant despite the object's proximity and movement through Earth's magnetically active environment. Similarly, low-orbit satellites capable of detecting plasma oscillations and electromagnetic disturbances recorded no fluctuations above background levels, no induced fields, no harmonic patterns, no irregular pulses, complete and sustained quiet. Typically, even inert celestial bodies generate some ULF signals. Small oscillations in the object's magnetic field, variations in surface conductivity, or interactions with charged interstellar dust can all produce detectable waves. For comets, sublimation and particle ejection often create microscale electromagnetic effects, visible in ULF and very low-frequency monitoring. 3I Atlas, however, displayed none of these expected signals, even as it maintained a perfectly aligned orientation toward Earth. The significance of this silence became clearer when correlated with previous observations. The object had already demonstrated thermal stabilization, polar pulse activity, spectral narrowing, controlled emission arcs, and radar cross-section manipulation, all of which indicated precise environmental control. The ULF quietness suggested an additional layer of sophistication. 3I Atlas was actively suppressing low-frequency electromagnetic interactions that would normally betray its presence. Several theories emerged to explain the phenomenon. One proposed a magnetically cloaked surface, capable of absorbing or rerouting local electromagnetic energy, preventing it from escaping into the surrounding space. This would account for the absence of ULF activity while maintaining stability in other domains. Another hypothesis suggested that the object's internal structure could dynamically neutralize induced currents, essentially cancelling detectable interactions with Earth's or solar magnetic fields. Both explanations implied a level of engineering far beyond natural astrophysical processes. The timing of the ULF quiet was also telling. The effect became most pronounced as 3I Atlas entered the region, where the emission arc and anti-tail were fully extended and aligned with Earth. The quiet persisted even as the object executed subtle orientation adjustments, suggesting that the suppression was not a passive property of the object, but an actively maintained phenomenon, dynamically responding to its environment. This quietness had practical implications for detection and tracking. While radar and optical systems could monitor the object, conventional low-frequency monitoring, a key tool for detecting charged interstellar objects, was effectively rendered useless. 3I Atlas could traverse sensitive regions of space without producing disturbances in bands normally reliable for early warning or environmental analysis. From a broader perspective, the quiet ULF band reinforced an overarching pattern, observed throughout the approach. 3I Atlas was a fully controlled, self-regulating system. Each anomaly, thermal, magnetic, optical, and now electromagnetic, pointed toward an object capable of sensing, responding, and minimizing detectable influence across multiple physical domains simultaneously. Its approach was not random. It was deliberate, calculated, and designed to maintain observational discretion even as it moved closer to Earth. In essence, the silence in the ultra-low frequency band was not just absence, it was control. It represented mastery over the subtle interactions of space, further confirming that 3I Atlas was operating according to rules entirely outside natural cometry or asteroid behavior. As it drew nearer, scientists realized that every detectable phenomenon was intentional, and every undetectable aspect, like the quiet ULF band, was just as telling of its unprecedented sophistication. As 3I Atlas continued its trajectory toward Earth's orbital corridor, an unexpected phenomenon emerged from solar wind observations. Instruments aboard the ACE spacecraft, SOHO, and Earth-based solar wind monitors began detecting a subtle, yet consistent deviation in the flow of charged particles as they approached the object. Normally, the solar wind, a steady stream of protons and electrons emitted by the Sun, flows relatively uniformly through interplanetary space, only slightly perturbed by planetary magnetospheres or natural cometary outgassing. But with 3I Atlas, the pattern was anomalous. The solar wind appeared to curve around the object, bending as if encountering an invisible barrier. The effect was first noticed when high-speed solar wind particles, travelling at hundreds of kilometers per second, showed a directional shift of just a few degrees near the projected path of the object. While minor in absolute measurement, the pattern was repeated across multiple datasets and correlated with the object's leading edge. Subsequent cross-checks with magnetic field data revealed no corresponding spikes or fluctuations, ruling out conventional magnetospheric interactions. The bending was neither caused by turbulence nor solar wind instabilities. Instead, the streamlines consistently diverted around the object, forming a smooth, coherent curvature. The behavior was remarkable. Even highly conductive natural bodies, such as metallic asteroids, cannot significantly redirect solar wind without creating measurable electromagnetic or particle effects. Comets, with active outgassing, produce visible ion tails that trace solar wind interaction, but 3I Atlas produced no detectable ion emissions, no heat, and no residual plasma while the flow curved neatly around it. The implication was clear. The object was passively or actively influencing the solar wind in a controlled manner. The observed curvature coincided spatially with the object's emission arc and anti-tail orientation. Models suggested that whatever was causing the redirection was localized within a narrow region immediately surrounding the object. The wind did not deflect randomly. It followed a smooth path consistent with a boundary defined by the object itself. The effect resembled a plasma shadow, a low interaction zone guiding charged particles along a controlled trajectory. Researchers explored several potential explanations. One hypothesis involved electrostatic influence. A charged surface or envelope could repel incoming ions, producing the observed curvature without thermal emission. Another considered electromagnetic shaping. The object could generate localized fields, subtle enough to guide solar wind while remaining undetectable in the ULF and magnetic bands. Either scenario implied an extraordinary level of control over environmental forces. Moreover, the curvature's alignment with Earth-facing orientation suggested intentionality. The deviation was strongest when 3I Atlas's axis aligned with the orbital plane and diminished slightly as it rotated away, indicating that the object could modulate the interaction dynamically. This echoed prior anomalies, emission arcs, radar cross-section amplification, polar pulses, and thermal stabilization, all of which suggested a system capable of adjusting to surroundings in real time. The solar wind's behavior also had implications for modeling. Standard projections which assume uniform plasma flow no longer applied. Predictive calculations for drag, minor orbital deflections, and trajectory evolution became more complex, as the solar wind could no longer be treated as an independent, unaltered environment. The object was shaping space itself, subtly, silently, and with precision. For Earth-based observers, the effect was both fascinating and unsettling. The object's ability to bend charged particle streams without detectable energy expenditure or conventional propulsion reinforced the growing consensus that 3I Atlas was an adaptive, self-regulating system, capable of controlling interactions across multiple physical domains: magnetic, optical, thermal, and now plasma dynamics. In essence, the solar wind did not simply encounter 3I Atlas. It negotiated with it, bending around an invisible boundary as if respecting a rule set imposed by the object. And as it approached closer to Earth, this silent mastery of interplanetary forces signaled that 3I Atlas was far more than a mere celestial visitor. It was a system operating with intention and sophistication beyond anything humanity had observed in natural interstellar objects. As 3I Atlas drew closer along its precise orbital corridor, scientists and observatories focused on a new set of measurements: gravitational influence. With an object of its estimated size and mass moving into the inner solar system, even minimal gravitational perturbations should be detectable. Minute tidal effects, shifts in Earth's magnetosphere, or slight anomalies in satellite trajectories could all indicate a growing pull. Yet, despite its approach, there was no measurable gravitational tug on Earth. Sensitive instruments from geophysical monitoring stations around the globe recorded baseline measurements across multiple axes. High-precision gravimeters in North America, Europe, and Asia remained consistent, showing no deviations beyond normal environmental noise. Satellite positioning data confirmed the same. No detectable perturbation in orbital parameters of Earth-orbiting objects. The calculated tidal influence of 3I Atlas, given its distance, should have been subtle but observable. It was not. The lack of gravitational effect was particularly noteworthy in context. 3I Atlas had demonstrated a consistent pattern of active environmental interaction: emission arcs, polar pulses, tail expansion without core venting, and ULF silence. These observations implied precise control and energy management, yet none of it manifested in a gravitational pull. The object's approach was guided, aligned, and deliberate, but it remained invisible to Earth's gravitational instruments. Researchers proposed several explanations. First, the simplest. The object's mass, while significant by interstellar standards, was insufficient to produce measurable tidal effects at its current distance. Calculations based on estimated volume and assumed density supported this hypothesis, but the consistency and precision of the other anomalies suggested something more profound. The object might be actively minimizing detectable gravitational signatures. Another possibility considered was a subtle form of mass distribution control. If 3I Atlas could redistribute internal mass dynamically, analogous to gyroscopic stabilization, it might maintain momentum and orientation without producing a detectable gravitational field along Earth's line of observation. In essence, the object could be balancing itself in such a way that its influence on distant bodies remained effectively neutral. This interpretation aligned with prior observations. The absence of acceleration noise, the thermal equilibrium across the surface, and the deliberate tail manipulation all suggested a system capable of fine-tuned environmental control. The lack of gravitational perturbation was simply another dimension of this control, silent, precise, and undetectable. The timing of these measurements was critical. As 3I Atlas approached Earth's orbital plane, researchers expected incremental increases in gravitational effects due to proximity. Instead, the instruments recorded absolute stability, a perfect course maintained without perturbing the local environment. The object's trajectory, orientation, and rotation remained imperceptibly controlled, demonstrating a mastery over both motion and influence. This absence of gravitational pull also had implications for predictive modeling. Conventional orbital simulations, which assume natural interstellar bodies obey Newtonian mechanics strictly, could not fully reconcile the observations. While trajectory and position data matched calculated gravitational predictions for mass and velocity, the lack of secondary effects, tidal, rotational, or orbital disturbances, indicated an adaptive system overriding natural interactions. For observers on Earth, this was another confirmation of 3I Atlas's extraordinary nature. It moved with purpose, aligning perfectly with Earth's position, modulating emissions, bending solar wind, controlling its tail, and now maintaining zero detectable gravitational influence. Every measurable and unmeasurable aspect suggested a highly controlled, responsive system, operating in a manner far beyond conventional celestial mechanics. In essence, 3 Atlas was approaching without leaving any gravitational signature. The planet remained unaffected by its presence, even as the object orchestrated a sequence of increasingly sophisticated interactions. And as it continued its silent, precise approach, this lack of gravitational influence would become yet another indicator of the object's unprecedented capabilities and potential intent. As 3I Atlas drew ever closer along its carefully maintained trajectory, instruments monitoring its optical and infrared characteristics detected a subtle yet remarkable phenomenon, an increase in internal glow. Unlike surface reflection, tail brightness, or emission arcs, this glow appeared to originate from within the object itself, subtly radiating through its previously uniform and reflective shell. The first detection came from the Keck Observatory, using adaptive optics to isolate the object from background stars. Observers noted a faint diffuse luminosity that did not correspond to external illumination from the sun. This glow was symmetrical, emanating evenly from the visible surface, yet it appeared slightly more intense along the object's leading axis, the side facing Earth. Subsequent confirmation from the Very Large Telescope in Chile and the Subaru Telescope in Hawaii reinforced the observation. Multiple spectral bands, optical, near-infrared, and ultraviolet, registered this phenomenon independently, ruling out observational artifact. The characteristics of the internal glow were perplexing. Unlike thermal emissions observed earlier, which had been regulated and stable, the glow increased gradually over time. Its intensity varied slightly in sync with the object's rotation, suggesting a controlled modulation rather than random variation. The glow did not produce any detectable heat gradient in surrounding space, maintaining the prior radiative freeze and ULF silence. In other words, 3I Atlas was producing internal illumination without affecting its environment, a feat unseen in natural interstellar objects. The implications were profound. A glowing interior suggested energy generation or redistribution within the object. Combined with prior anomalies, tail expansion without venting, spectral narrowing, and polar pulses, the glow implied that 3i Atlas was actively managing its energy internally, selectively channeling it to influence visibility while maintaining surface and environmental stability. The glow's subtlety indicated it was meant to be detectable, but only under precise observational conditions. Several hypotheses arose. One proposed that the internal glow resulted from photonic or luminescent materials embedded within the object's structure, designed to radiate light selectively through the reflective shell. Another suggested controlled plasma emission, or electromagnetic resonance, producing visible light without accompanying heat or magnetic disturbance. Both explanations indicated a level of internal engineering or adaptation far beyond any natural comet or asteroid. The glow's orientation reinforced its deliberate nature. It was strongest on the Earth-facing hemisphere, coinciding with periods when the emission arc and anti-tail were fully formed and aligned. This synchronization suggested that the glow served a purpose, perhaps a signaling function, a method of enhancing reflectivity, or a form of environmental scanning. Its subtle pulsing in harmony with rotation and polar pulses hinted at integrated systemic control, uniting multiple observable anomalies into a coordinated sequence. For astronomers, the observation marked another critical insight. 3i Atlas was not merely a passive interstellar object responding to solar and gravitational forces. It was an active system capable of regulating internal energy, controlling external signatures, and interacting with its environment in a precise and deliberate manner. The internal glow was a visual confirmation of this capability, evidence that the object possessed not only structural integrity and surface control, but also dynamic, energy-based adaptability. Moreover, the glow provided clues about the object's potential internal composition. Its uniformity suggested a dense, possibly conductive interior capable of channeling energy evenly across vast distances within the object. The absence of surface disruption or thermal leakage implied advanced insulation or energy distribution mechanisms, further reinforcing the notion that 3i Atlas was operating with a level of sophistication unmatched in naturally occurring celestial bodies. In essence, as 3i Atlas moved closer to Earth, its internal glow increased gradually, serving as both a subtle signal and a testament to its unprecedented internal control. This phenomenon added another layer to the growing picture. 3i Atlas was a highly adaptive, responsive, and extraordinarily precise system, orchestrating multiple anomalies in harmony while approaching the planet. After weeks of unprecedented observations monitoring 3i Atlas in its precise approach toward Earth, the final anomaly manifested. The object stopped, not in a catastrophic sense, not through collision or disruption, but in the complete cessation of all previously active behaviors. Every measurable signal, every emission, every movement anomaly halted simultaneously, as if the object had entered a state of deliberate stillness. Optical instruments confirmed the stillness first. The previously dynamic emission arcs and anti-tail alignment ceased all fluctuation. Photometric readings showed a flat, stable light reflection, with no modulation corresponding to rotation or polar pulses. The internal glow, which had gradually increased over previous hours, stabilized and then began a subtle fade, blending seamlessly into the reflective surface. High-resolution imaging indicated the object no longer exhibited the minor orientation shifts observed in prior days. It was frozen, perfectly aligned along its Earth-facing axis. Thermal and electromagnetic instruments reflected the same phenomenon. The radiative freeze, which had already minimized infrared emissions, continued without interruption. YOLF and low-frequency bands remained silent, as they had during previous approaches. Radar cross-section readings, which had tripled due to previously active modulation, stabilized at a constant value. No residual disturbances, no pulses, no fluctuations. 3i Atlas had become entirely inert to detection, yet remained fully intact. The absence of acceleration noise was particularly remarkable. In the past, even minimal micro-adjustments produced detectable rotational shifts. Now, none were observed. Orbital tracking confirmed that 3i Atlas held its trajectory perfectly. Velocity and course remained constant with uncanny precision, despite the absence of observable propulsion or dynamic adjustment mechanisms. The object's motion adhered strictly to predicted orbital physics, yet all previously active, adaptive behaviours had ceased. Astronomers quickly realised the implications. This was not mere stasis. It appeared to be a controlled pause. In prior observations, 3I Atlas had exhibited systematic modulation, brightness reflecting Earth's position, anti-tail formation, emission arc shaping, polar pulses, tail expansion without venting, and internal glow. Each anomaly had served a functional purpose. Now all processes had shut down simultaneously, leaving the object in a state of deliberate inactivity. Researchers considered potential explanations. One hypothesis suggested that the object had completed its observational or preparatory sequence. Every prior behaviour, tail manipulation, polar pulse, spectral narrowing, internal glow, had been part of a coordinated program. By stopping, 3I Atlas signalled the end of its active phase, entering a stable, passive state until the next environmental cue or gravitational influence demanded further adjustment. Another consideration focused on energy conservation. Maintaining internal glow, emission arcs, and environmental manipulation required energy management on a scale previously inferred but never directly measured. The cessation of activity could indicate that the object had reached a balanced energy state, where further motion or emission was unnecessary. In this context, stopped did not mean inertness in the traditional sense. It meant optimized stillness, a state of equilibrium across thermal, electromagnetic, and orbital parameters. The object's alignment reinforced this interpretation. The axis facing Earth remained precise, unchanged from its previous orientation, suggesting that this final pause was intentional. Every adaptive system had shut down in a coordinated manner, leaving 3I Atlas perfectly poised, silently waiting, yet fully prepared for any further environmental interaction. For Earth-based observers, the stillness was both reassuring and unsettling. It provided a rare period of stability for measurement and analysis, yet it emphasized the sophistication of the object's control. Here was a body that had actively manipulated every detectable aspect of itself across multiple physical domains, and now ceased all activity without losing alignment, coherence, or structure. In essence, the stopping of 3I Atlas marked the culmination of its approach phase, a perfect, deliberate pause. Every previous anomaly, emission arcs, anti-tail formation, polar pulses, internal glow, radar amplification, and environmental interaction had built to this final state. And now, in its silence and stillness, the object stood as a testament to an unparalleled mastery over motion, energy, and observational presence, leaving Earth's observers with a profound sense of awe and deepening questions about its origin, purpose, and next move.